Learn ROS2 in 4 hours. I'm gonna walk you through a comprehensive ROS2 course for beginners. We will cover the most important concepts and tools to get started with ROS2. I'm gonna show you how to install ROS2 on your computer, how to organize your workspace, and cover the fundamentals of creating ROS2 nodes with Python. Then we'll dive into topics, publishers, subscribers, services, parameters, and actions. This is a hands-on ROS2 tutorial. We will work with various projects throughout the course, and by the end we will integrate some electronics. I'm gonna show you how to process sensor data in real time using ROS2, Python, and Arduino. This course is ideal for beginners and anyone looking to deepen their skills in ROS2. I will be using the ROS2 Humble distribution, but the concepts and most of the code we will be creating is compatible with other ROS2 distributions as well. My name is Felipe, welcome to my channel, and now let's get started. Now let me show you how to install ROS2. This is from the ROS official documentation. You can see that there are different versions of ROS2 which are currently supported, all these versions over here. If I scroll down a little bit, you can see that all of these different versions, although they are currently supported, they have different levels of support. Some of them are fully supported, but then there are other versions of ROS2 with limited support or community support. All depends on your OS, right? So the first thing you will need to do in order to install ROS2 is to decide which version of ROS2 you are going to install. In my case, I am a Linux Mint user. Let me show you. I am currently using Linux Mint 21, and Linux Mint is based on Ubuntu. It's based on Ubuntu 22.04 Yummy Jellyfish. So this is my OS. So in my case, you can see that Ubuntu Yummy, the only version of ROS2 which is currently supported and it's fully supported and recommended to new users is ROS2 Humble. So this is the version I am going to install. Now let's get back here and I'm going to click on the documentation of ROS2 Humble. If you want to change the documentation to some of the other versions of ROS2, the only thing you need to do is to click here and you just need to select whatever version you want to select, right? You can see all the different versions are over here. But I'm going to stay here in Humble, and if I scroll down, I click here on installation, and I am going to install in my Ubuntu Yummy Jellyfish computer 22.04, so I'm just going to click here on the packages. And then in order to install ROS2, the only thing I need to do is to execute all these instructions one at a time. So I'm going to open a terminal, and I'm just going to run all these instructions. Okay, and this was the last one, the apt upgrade. Now let's move on. You can see that we have these three options over here in order to install ROS2. Regarding these two options over here, if I'm not mistaken, if I understand correctly, we need to install either this one over here or this other option over here, right? It doesn't make any sense to install both of them. So we need to decide which one are we going to install. This one over here is like the most comprehensive version, right? You can see that this is the recommended version. And then this other version over here is the bare bones version, which basically means that it's a version of ROS2 for resource constrained devices. For example, you do not have any GUI type of tools, so only go here for this option if you are working on a resource constrained device. So nothing happens in my case because I have already installed ROS2, but let's just move on. So the next step in this process is to install the ROS Dev Tools package. And something that's very interesting about this package is that it's not absolutely necessary. If you do not install it, everything is going to work just fine for now, right? For now, everything is going to work just fine. Let me show you, because I have been investigating what exactly it's included in this package. And I found this documentation over here which details exactly what the ROS DevTools package contains, right? You can see that it's made of these packages over here: Python 3 Bloom, Python 3 Colcon common extensions, Colcon mixin, ROS2, and these two packages over here. So from all these packages, the only one that I can tell you for sure it's very important is this one over here, which is Colcon. But the thing is, if you do not install Colcon now, you can install it later in the next step in this process. I'm going to show you in a few minutes. Just for the sake of simplicity, let's install the ROS DevTools package. But remember, this is only a collection of other packages which you can also install independently, right? Personally, I do not like the idea to just install a lot of packages just in case, right? I don't like to do that. I usually don't like to do that. But for the sake of simplicity in this tutorial, let's just install the ROS DevTools package, and that's it. So that's going to be pretty much all for the installation. Now let's see if everything is working properly. Let me show you what we have installed, right? Everything has been installed here in OPT ROS Humble. So I am going to show you what exactly I have installed in my computer. Okay, so I made the font a bit larger, so it's much easier for you to see what's going on. I'm going to enlarge the terminal, and let me show you something. Now if I ls into this directory, OPT ROS Humble, you can see that this is where we have installed ROS2, and we have a bit of everything. We have a lot of files, we have some directories. Let me show you what's inside this directory over here, the bin directory. This is where we have installed a few packages which we are going to use a lot. Some of them we are going to use a lot in our ROS2 development process. For example, this package over here, ROS2, we are definitely going to use it a lot. And we are also going to use some of the packages and files we have here in lib. If I ls now in the lib directory, you can see that now we have a lot of files. This is a bit of everything. We have some packages, for example, TurtleSim, for example, RQT Graph. We also have some Python packages. We have a bit of everything over here. If we intend to use, for example, this package over here, ROS2, I'm just going to type ROS2, and you can see it says command not found. And if I try to execute it by typing the absolute path to the package, it says not file or directory, because it's bin and then ROS2. Now it executes, we can see something, but it crashes immediately because something of some Python packages which were not found, right? So the thing is, if we want to make use of the ROS2 package we have installed, we will need to do something, and let me show you what exactly we will need to do. We need to source this file over here the way that it's explained over here. So now if I just copy and paste this instruction over here, and if I try to execute ROS2 again, now everything is okay, no error whatsoever. So long story short, very long story short, we will need to run this instruction over here every time we intend to use ROS2. So we can either run the instruction every time we intend to use ROS2 in a new terminal, or we can do something that is much simpler, which is just going to our bash rc file, and we can just include this instruction at the end over here. Now this means that the instruction is going to be executed every time we open a new terminal. Now if I open a new terminal like this and I run ROS2, everything is okay, everything is working properly. So this is going to be pretty much all for the installation. Now we have verified everything has been properly installed, everything's functional, everything's okay. Now let's move on to run our first program, just to make absolutely sure and 100% sure that everything is okay. So I'm going to try to run this example over here, which is running a talker and a listener. This is one of the demo examples from ROS2. So I'm just going to copy and paste this command over here. We're going to execute ROS2 run demo nodes cpp and then talker. And you can see that if I press enter, I have something here in my terminal. I have some output, and it's basically there's some process that is printing hello world, and then it's incrementing an integer, right? 12, 13, 14, 15, and so on. So now I'm going to open another terminal, and I'm going to execute this other instruction over here, which is the listener. And you can see that I'm going to open both terminals. Now we are listening to whatever it's publishing this other node over here, right? You can see that now everything started with hello world 32, which was the message which was published at the time we executed this instruction over here. Now if I end the process and I start the listener again, now we are starting in 57, right? If I terminate this other process, if I terminate the talker, now you can see that this one over here, it's still executing, it's still running, everything's okay, but it's just not listening to anything because no one is, because this one over here is not publishing any message. If I restart the process, you can see that now we are starting from the one again, right? 1, 2, 3, 4, 5, 6, and so on. So this is only to make sure everything is working. We still don't understand what's going on, right? We have one process over here that it's somehow publishing messages, and then we have another process over here that is somehow listening to all the messages that are being published over here, but we still don't understand what's going on, right? I'm going to explain what's going on in the next lessons in this course, but this is only to make sure that everything is working properly, and in order to make sure we start acquiring some experience, some practical experience on running some processes in ROS2. And now let's move on with installing Colcon. Colcon is the build tool we will be using in order to build our packages in ROS2. So I'm here in the ROS2 documentation, the ROS2 humble documentation, and I'm going to type Colcon over here. I'm going to go here to using Colcon to build packages, and then I'm going to show you something. If I scroll down, you can see that this is the instruction I need to execute in order to install Colcon in my computer. But remember that I have already installed the ROS dev tools package, and one of the packages that's included over here is the Colcon package we need to install over here. So in my case, it doesn't make any sense to install it again because I have already installed it over here. But if you have not installed Colcon, then you need to install it by running this command over here. In my case, nothing happens because I have already installed Colcon, but please remember to do it before you continue. And something that is very important about Colcon is that this is not part of ROS2, right? Colcon is an independent package that is used in order to build packages, right? If I show you here from the Colcon documentation, this is the Colcon official documentation, it says Colcon is a command line tool to improve the workflow of building, testing, and using multiple software packages. So it's very important for you to understand that this is not part of ROS2. This is like an independent package that we will be using in order to build our packages in ROS2. And if you have any questions regarding how Colcon works, then please check out Colcon's official documentation over here. I think it's very useful because it has a very detailed description of all the different commands you can use using this tool. For example, this is a command we're going to use very often, which is build, and we are going to use some of the arguments that we have over here, but I'm going to show you later exactly which arguments we're going to use and why. And the thing is, if you have any questions or if you want to understand the topic a bit more deeply, right, with more details, then please make sure to check out this documentation over here, and you're going to see a very detailed description of absolutely everything you can do using Qualcomm. Okay, now let's move on, and let me show you something that is very commonly used when working with Qualcomm, which is, if I scroll down over here, says setup Qualcomm tab completion. And this is something that is not absolutely needed, is not required. If you do not do it, everything is going to work just fine. But this is going to enable a very interesting feature which is very commonly used. So let me show you how to enable this feature. I'm going to click here in some setup may be required. And you can see that pretty much the only thing we need to do is to follow these instructions over here. So we need to add to our bash rc this command over here. In our case, we are here. So if I ls this directory, you can see that if I ls this directory, these are the two files I have over here. So I need to source this file, and in order to make this available to absolutely every single terminal, I will need to do exactly the same as I did before with the other source I did a few minutes ago, right? So this is what we will need to do. But in order to avoid the hassle of doing exactly the same and running exactly the same instruction every time we open a new terminal, I'm just going to copy and paste this instruction over here. I'm going to copy and paste this instruction in the bash rc file. So I'm just going to open this file over here, and I'm going to paste the instruction over here. Okay, right next to this other instruction of sourcing the setup.bash file of the humble version of our ROS2 installation. So I'm going to save the changes, and that's going to be pretty much all. Okay, so this is a very important step because you need to make sure that we have installed Qualcomm in order to continue. Now let me show you something which has to do with how we're going to organize all of our development process while working with ROS2. So let me explain exactly what we have over here. We're going to create a workspace, and this workspace is going to be something like a development environment, something like that, which is going to include all the different packages and everything we create while working with ROS2. So we're going to create packages, and each one of these packages is going to include a lot of nodes. Right, so it's very important for you to get familiar with these terms over here: node, package, and workspace, and to have a high level idea of exactly what they are, right? So we're going to have a workspace. The workspace is going to include a lot of packages, and each one of these packages is going to include some nodes, right? Then when it comes to the nodes, you can think about a node as a process, or as a program, or as a script we will be running, we will be executing in order to produce some effect. For example, earlier today I showed you two different nodes which are available in the ROS2 demo packages, which is the talker and the listener. Although we still don't understand what was going on under the hood, for now, we just keep in mind that we had two nodes. One of them was a talker, and it was publishing messages, and then the other node was a listener, and it was somehow listening to all these messages. So we had these two nodes, and these are very specific examples of some programs, some scripts we were executing in order to accomplish something, right? In order to produce a given effect. So each one of these nodes is going to be a collection of instructions we are going to execute in order to produce an effect, right? That's a very simple way to understand what a node is. I'm going to show you a bit more closely later today because I'm gonna show you how to create our own nodes, right? But for now, this is a very simple and high level explanation. So let's move on creating our own workspace and creating our first package. Let's see how to do that. So I'm going back here to the terminal and I'm going to create a new directory which is going to be called ROS2 workspace, right? ROS2 WS. This is a very usual name when working with ROS2, when creating a new ROS2 environment. The thing is, you can call this directory whatever you want and everything is going to work just fine, right? This is a very usual name, but you can call it whatever you want. But then we're going to create another directory, which is src, right? This is going to be the name of this other directory, src. And this other directory is very important to call it like this, exactly like this, because otherwise things are not going to work. So we have created our workspace. And we also create this directory over here, which is very important. Now let's get back to ROS2 documentation. And let's go to this page over here, which is creating a package. Let's create our first package. And you can see that I'm here in tutorials, beginner client libraries, creating a package. If I scroll down, you can see that as a prerequisite of creating a package, we will need to create a new environment, a new workspace. And you can see that the name that is used here in the documentation is the same name I'm using in my computer, which is ROS2WS. And then we will need to execute one of these two instructions depending on if we're going to create a C++ package or a Python package. So in my case, I'm going to select Python and I'm just going to copy and paste this instruction over here. You can see that we have a few options, but let me explain a bit better here. I'm going to cd into ROS2 workspace src, and now I'm going to execute this command over here. So you can see we have this argument. Now we are running ROS2 pkg create. This is how we're going to create a package, and the build type will be amend Python. This is how we're going to specify that we're going to create a Python package, right? We will be coding in Python. And then this other argument over here, this is the license. We don't really need the license for this tutorial. This is not a mandatory argument, so I'm just going to delete it. And then we need to specify the package name, which in my case, I'm going to say something like my new package. And if I press enter, you can see that now we have created a new package. We have a huge output over here. This is a lot of information, but for now, just stay with the idea that this is how we're going to create packages. You can see that we also had other arguments. If we go to, let me show you something. If I go to ROS2, package, create, help, you can see that we have many arguments we can use over here. The license is one of them. And we also can specify the dependencies. This is something that we may use later because it's a very important argument in order to specify what are the Python packages we need as dependencies for this package, and so on, right? We have many arguments over here. But for now, in order to keep it simple, let's just create a very simple package like that. And now let's move on. If I ls, you can see that this is the package we created. Now I'm going to build this package using Colcon. So let's see how to do that. And this is actually going to be a very simple process. The only thing we're going to do, we are going to go here to the root directory, to the workspace directory, and we are going to type Colcon build. And that's going to be pretty much all. I'm going to show you an argument we are going to use very often when building our packages. If we go here to the Colcon documentation, right? We are in Colcon build, And let me show you from all these arguments we have over here, this is an argument we're going to use very often, which means that we are going to use symlinks instead of copying files from the source and build directories where possible. This is going to help us a lot, and I'm going to show you exactly how, right? I'm going to show you exactly what happens if we do something like this. I'm going to run this command. You can see that it's building the package, and now everything has been built and everything is okay. Now it's time to make our custom node in Python, and let me show you how to do that. First, let's get back here to the ROS2 official documentation, because I want to show you something about IDEs. If we're going to be doing some coding in Python, ideally we would like to do it from an IDE. But let me show you this. ROS2 is not made around a specific development environment, and the main focus is on building running from the command line. Very interesting. Nonetheless, IDEs can be used to develop, run, and or debug ROS2 nodes. Okay, so it seems we can use IDEs, although the main focus is on building running from the command line. Okay, now if we scroll a bit down over here, we have these two tabs, Visual Studio Code and PyCharm. Let me show you first what it says about PyCharm. We have some instructions over here, but if you notice, regarding PyCharm, it says this is untested. So it seems it's possible to use PyCharm, but it is untested. So in my case, I preferred to use Visual Studio because it seems it's more widely supported. That's my understanding by inspecting this page over here in the documentation. So I'm going to be using Visual Studio Code, and I recommend you to do the same based on what I understand from the documentation. So basically the instructions say that we need to start Visual Studio Code from the same command line we used in order to source ROS2 and everything we had been sourcing in this tutorial. That's the instruction here from the official documentation, but in my case I have already added everything to bash RC, so if my understanding is correct, I do not necessarily need to start Visual Studio from the terminal, right? I think if I start Visual Studio Code as I will normally do it, I think everything should work just fine. So this is how I am going to do it, but in your case, please mind these instructions over here, and perhaps in your case you prefer to follow the instructions exactly as it says here, right? Now let me show you something else. This is Visual Studio Code. I am going to open the folder of the workspace we have created, and also the src of our new package. I'm going to open, and in my case this is already open there, right? So let me show you the file structure we have created in our package. You can see that this is src, this is my new package, and inside my new package we have another directory which is also my new package, and this is the directory where we will be creating all the Python scripts in this project. Then we also have other files and directories over here. Let me show you these two files, which perhaps are the most meaningful files, setup.py and package.xml. Setup.py, we have some information, but for now just remember we have this package over here. I'm not going to edit the file extensively. You can see it's everything is the default values, and everything is like, it's pretty much empty, right? The only thing I'm going to edit later on is over here in entry points, right? This is going to be done later, so let's take it one step at a time, but this is just for letting you know this is the part we will be editing from this file. Then if I go to package.xml, we also have a lot of information, and the only thing I will be editing over here is adding all the dependencies in this project, all the Python packages we will be using in order to make this node work. So I need to create a new entry over here, and I need to call this depend, and then I'm going to say that RCL PI It's one of the dependencies in this project. This is very important. Don't forget to do this because otherwise it's not going to work. RCLPY. So this is the Python package we will be using in order to create our node. Now let's get back here, and I'm going to create a new Python file, and I'm going to call this file something like node example.py. Okay, and this is going to be a very straightforward process. Remember, we are just getting started with creating a node, so we want to make everything as simple as possible for now. So I'm going to import RCLPI, which is the ROS2 library. This is the library we're going to use in order to communicate with the ROS2 package. And I'm also going to import from RCLPI.node import node. I'm going to create a function which is main. This is going to be args equal to known, and I'm just going to leave it empty for now because let's create this other part over here in order to make sure we can execute this file as a script, right? Okay, now every time we execute the file, we're going to be executing this function over here. Everything is okay. And in order to move one step at a time, let's just do something like this. We are going to initialize our ROS2 communication, right? We're going to initialize the communication with ROS2, and we're going to say something like this. Okay. Then we're going to define a new node, and this is going to be something like this. And this is going to receive the name of the node. So this is something like example node name, something like that. And then let's print on screen something like node get logger let's print something like hey. And that's pretty much all. And then the only thing I'm going to do is to shut down this node, and that's all. Okay, I'm going to press save, and now let's get back here. Remember, I told you we need to make a change in the setup.py file, and we need to make a change here in the entry points. So this is what we are going to do. I'm going to define a new entry, and this is going to be example node executable. This is going to be equal to the package name, which is my new package dot node example, which is the file name, and then we will need to specify the function we are going to execute, which in our case is main. Okay, now let's go to our terminal and let's build the project again. We need to do something like this. I'm going to cd into ROS2 workspace, and now we're going to build this package again. We need to build the workspace again, so I'm going to do something like colcom build, and let's we use the same argument as before. I'm going to press enter. Okay, everything has been successful. Now let me show you something super quickly. Let me show you exactly what we are doing over here when using this argument. Perhaps the easiest way to do it is just calling the help like this. And let me show you over here. Basically, what we are doing under the hood every time we use this argument is that we are using symlinks instead of copying files where possible. So this is going to be a very interesting thing to do in our case, because We want to use this Visual Studio environment only to make core development efforts much easier, but actually we want to be on a very close loop, coding and then testing and then making sure everything's okay, right? So we don't want to be building our workspace continuously every single time we want to make a new test, right? And this is going to help us a lot because we are just going to create a symlink to the Python scripts. So then every time we make a change in the Python scripts, then we will not need to make the build again. If you're not familiar with symbolic links, you can think about it like a reference to another file. So every time you create a symbolic link, the only thing you have is a pointer, is a reference to something else, right? So we are not copying the Python scripts. We are just keeping the Python scripts in their directory, and we are creating a symbolic link that references to the Python scripts. So every time we make a change in the Python script, we will not need to build the project again, and that's going to be very helpful. Okay, now let me show you something. If I try to execute the package we created, I will have a situation like this. I'm going to execute ROS2, run the package name, which is my new package, and then the node name, which will be something like this. But if I try to do it, it says my new package not found, because we will need to make sure ROS2 is able to find the package we created. Now, if I ls into the install directory, you can see that I have many files over here, and I will need to source this file we have over here, which is setup.bash. So source install setup.bash. Okay, and now if I try to do the same, run the same command again, now, okay, we have an error because I made a mistake. We don't have to, we don't need to shut down the node. We need to shut down the communication with RCLPI. So this is what we need to do. I'm going to save the script, but I'm not going to build the project again. Now, if I just go here and I try to execute it again, now you can see that we are running something. We are running something because we can see hey here on screen. But you can see that we have executed the file and we have terminated the execution immediately, right? So everything is working properly, but we will need to do something if we want to keep the script running. So let's do something else. Let's get back to Visual Studio and let's do something else, because we want to be in a situation a bit similar to the example I showed you, where we had a node which was publishing a message permanently, right? The execution was running permanently, and this is something we ideally we would like to be in a similar situation. So let's see how to do that. We are going to continue using the same example as before, but I'm going to add an instruction over here, which is rclpi.spin, and I'm going to input the node we created. Now we are going to keep this node running, and we are going to be executing the node continuously. Let me show you. Now if I run the same package again, you can see that we are printing hey, but we are not terminating the file. So the node is still running, and we are not doing anything because we are only executing this instruction once, but you can see that we have not lived the script. Now let's make this example a bit more complex, right? Let's try to make this running in a loop, so we print the same text over and over again, and this is going to be somehow similar to the example I showed you earlier today with the talker, right? Let's see how to do that. So I'm going to make the entire code a bit more complex, and now we're going to define a custom class for a custom node, and this is going to be something like, let's call this custom node. This is going to inherit from the node class, and it's going to be something like this. The first thing we need to do is to define the constructor. This is going to be init, and let's make it similar to this other constructor over here. So we are going to input the class name, right? Something like that. Okay. We're going to call the parent class, and we're going to input the name. And then, other than that, we are just going to try to make everything that we were doing here over there, right? So we are going to, now this is going to be custom node, okay? And the logger now will be over here. But this is self. Okay, this should work just fine. Let's take it one step at a time. Let's see if it works. So I'm going to run it again. It doesn't, because I forgot to do something, which is adding this thing over here. This is the way to do it. Now if I get back here and I run the same example again, now you can see that we are executing the same, everything is exactly the same as before. So far so good. I'm going to clear this terminal, and this is how we are going to continue, because now the only thing we have made is a custom class for our node, and now we are just executing this instruction here instead of here where we were doing it before. But now we are going to create a callback, because we need to make sure that we are executing this function continuously into something like a loop, right? So this is how we're going to do. I'm going to create a timer. So this is going to be self create timer. This is going to input the timer period, which let's set it in something like 1 second. And this is going to call a callback, which I haven't defined so far, but we are going to define it like this, self callback. Okay, now let's define this function. This is going to be def callback, and let's just input self, and this is where we are going to execute this instruction. So now we're going to be in a situation that for every second we print this message on screen, right? We are going to call this callback every second. Let's see if it works. I'm going to get back here. Now you can see that we are in a loop, right? We are executing the same instruction every 1 second. If I terminate it and I increase it to 2 seconds, now it's exactly the same, but now we are executing the instruction every 2 seconds. So this is how we can create our own custom node in ROS2. Let me show you something else. Remember what we needed to do when we were sourcing the file, right? Remember earlier today I showed you that in order to make it work, we needed to source, install, and then setup.bash, right? Because otherwise ROS2 is not able to find the packages we created. So this is something we will need to do every single time we open a new terminal and we wanna use this package. So in order to make it much simpler in this tutorial, I'm going to add this instruction to the bash rc file. So I'm going to do something like print working directory. We are here. And I need to add something like this and then this over here. Okay, so now I'm going to open bash rc. And I'm going to do something like source this instruction over here. Okay. Now, if I open a new terminal and I want to use this package, everything works just fine. So the node we have just created is very functional, it works very well, but it's not really doing anything, right? It's very basic, and the only thing it does is to print hey on screen, right? It's not really doing anything of value. Now let me show you what a topic is, and let me show you how we're going to use topics in order to make more complex systems. Basically, a topic is a way to exchange information between nodes, right? You can think about it like a communication channel, which we are going to use in order to exchange data between all the different nodes we could have in our system, right? And we will say that a node is publishing data to a topic when the node is sending data to the topic, right? And the node will be subscribed to the topic when it's going to be consuming data from the topic, right? So let me show you an example, because this is going to be much easier to understand if I show you an example. And I'm going to show you another utility we're going to use from ROS2, which is RQT graph. This is a very useful user interface, a very useful graphical interface in order to visualize all the nodes which are currently running in our system, and also to see how they are exchanging data between them, right? So currently we don't have any node running, but let me show you. Let's run the same example as earlier today. I'm going to run the talker. I'm going to, now we are sending data, we are publishing data. And if I refresh, you can see that now we have a node, which is talker. I'm going to open another terminal, and this one will be the listener. Okay, and we are listening data, and you can see from over here. So now if I refresh, you can see that we have the talker, the listener. These are the two nodes we have executed, that we are executing, and they are exchanging data using this topic, which is called chatter. Now let me show you something else. If I go to another terminal and I type something like ROS2 topic list, this is going to give me a list of all the topics which are currently being used, and you can see that this is where we see the one we are using over here, which is chatter. Now let me show you something else. We can also use something like topic info and then the topic name, in order to have a bit more information of this topic, right? Currently we have only one publisher, which is publishing data into this topic, and we have only one node which is subscribed to this topic. And this is the data type of this topic, which is this data type over here, standard messages, message string. Right, there are various data types in ROS2 in order to communicate data, in order to publish data to a given topic, and I'm going to show you a few examples later on this video, but this is only to show you a bit more information of how this topic chatter works. So you can see that we have the count of how many publishers are publishing data into this topic and how many subscribers are subscribed to this topic, because this relationship of publisher subscriber could be multiple, right? We could have multiple publishers which are publishing data into the same topic, and we could have multiple subscribers which are subscribed to the same topic. So it's very valuable to have this information over here by just calling topic info, right? So now let me show you something else. Let's execute other nodes. I'm going to show you ROS2 run. Let's execute two nodes which are very popular from the Turtle Sim package. This is Turtle Sim node. You can see that this is a node that appears to be something like a turtle in the middle of the ocean, right? Because everything is blue, and the turtle for now is not really doing anything. So let's open another terminal, and now let's run ROS2 run Turtle Sim, and now we are going to execute draw square, and you can see that now the turtle is moving, And if we wait for a few minutes, the turtle is going to describe a square, right? So if I go to graph, if I go to RQT graph again and I refresh, you can see that now we have two graphs. We have the talker and the listener, which are still running over here. We have the talker and the listener who are exchanging data using the chatter topic. And now we also have these two nodes, draw square and turtle sim, and they are exchanging data using the topics turtle1 command bell and turtle1 pause, right? And you can see that this is a bit more complex. I'm going to stop these other nodes, the talker and the listener. So now everything's going to be a bit more clean. You can see that this node over here, draw square, is subscribed to turtle1 pause, and it's publishing data to turtle1 command bell. And you can see that turtle sim is publishing data into turtle1 pause, and it's subscribed to this other topic over here, right? So this is also possible. We could have a loop like this of two nodes exchanging data like this, and this is very not only it's possible, but it's very common in different use cases. Okay, so our turtle is describing a square. And now let's just before stopping everything, let me show you. If I open another terminal, now let's run again ROS2 topic list. And you can see that we have these two topics over here, and we have an additional topic, but we don't see this topic over here because this seems to be used by only one of these two nodes, right? For example, if I stop this one and I refresh, now you can see we only have one node. But this node over here is still publishing data into the same topic as before, and it's still consuming data from the same topic as before, but we don't see it because we don't have a closed loop, right? So I'm going to run it again. Okay, and that's exactly what we see over here. Although we can see only these two topics over here, it seems we have another topic which is being used by either one of these two nodes. It doesn't matter. So now let's continue. Now let's see some information. If I do ROS2 topic info command bell, this has only one publisher and one subscriber. That's okay. And the data type is geometry messages message twist. If I inspect the other topic, now this receives data of type turtle sim message pause, and let's inspect this other topic too, right? Let's see what's going on over there. And the data type is turtle sim message color, and this has only one publisher, but it has no subscriber. That's why we are not seeing this topic over here. But anyway, this is only to show you with a few examples how this works, right? How we use topics in order to exchange information between nodes. And now let's move to Visual Studio and let's make a much more complex example where we will be using a topic and we will be publishing data to a topic. Let's see how to do that. And let's create a node we can use in order to control the turtle like we are doing right now with draw square. For some reason it's not describing the square anymore. Let's see if I stop. Okay, now it's moving. It seems there's a bug or something. Anyway, let's create another node we can also use in order to control turtle sim, and let's make the turtle to do something else, something different. Let's see how to do that. So I'm going to stop everything. And I'm going to Visual Studio Code. And let's create another Python script. So I'm going here. This is going to be a new file, and the name will be, let's do something like, let's call it move turtle for now, and this is going to be move turtle.py. I'm going to copy and paste the code we have over here. We're going to make some changes, but for now let's just copy and paste. Okay, now this is going to be a custom turtle operator, something like that. It doesn't matter, right? It's just to create a custom class in order to use in this example. So now this is going to be something like this, and that's pretty much all. We can just leave everything the same as before, and that's pretty much all. And in order to move the turtle, let's use the data type we noticed in command bell, right? Let me show you other commands you can use as well, which are ROS2, interfaces, list. Sorry. Okay, interface list, and the data type was something like this, right? Geometry messages, message twist. So I'm going to copy this data type, and now I'm going to import from geometry messages, message, import twist. Okay, we're going to use this library as well, and I'm going to package XML, and I'm going to add this library as a dependency. This is very important. Okay, perfect. Let's run the same example again. ROS2 run turtle sim draw square. And now let's ROS2 run turtle sim turtle. Okay, and let's remember exactly what's the topic name. Command bell. Okay, we need to publish data into this topic, so we're going to do something like this. I'm going to create a new publisher, and this is going to be self create publisher. The data type will be twist. This data type over here, we're going to publish data using this data type. The topic name will be this topic name over here. And then we need to input another parameter, which I'm going to set in 10. I'm gonna share more details later on, but for now, let's just complete all the code. Perhaps it's better I show you right now, right? Because otherwise I may forget if I do it later. So let's go back to the documentation, to ROS2 official documentation. And this is the function we are using right now, right? Create publisher. So this is going to be rclpi.node.create publisher. If I go to the documentation over here, this is the method we are using right now, create publisher. And you can see that we have the message type, the topic, and then this parameter over here is the QoS profile. So this is the description of exactly what this parameter is about, right? What this parameter is about. And if you want to know more about quality of service, which is the QoS, means quality of service. If you want to know more about it, then I also invite you to check this part of the documentation where you have a very detailed explanation of what this parameter is about, right? I will say this is a bit of a more advanced thing of ROS2, so we don't really need to knock ourselves out and understand exactly what it is about. I think for this tutorial, let's just use a value of 10, which is a very common default value, and let's just move on. But if you want to know more details of exactly what this QoS, this quality of service, is about, then I invite you to check the ROS2 documentation out. And I'm going to call this variable something like publisher. Okay, this is going to be our new publisher. And let's continue using the same timer and the same callback as before, but now we will need to change the code that is being executed every time we call this callback. Now we're going to define the message like this. Remember, we will be publishing messages into the topic. The message will be an object of this class twist. And now let's see exactly how to write the message. And then once we write the message, we are going to publish the message over here. Okay, this is pretty much all. Something like this should ideally work very well. We're not really writing anything, but let's just see if it works with an empty message, right? Let's see exactly. Oh. Self get logger. I can just copy paste it from here. Let's see exactly what's inside of this message over here. But let's try to execute it, and in order to execute it, we need to go here, setup.py, and now we need to add a new instruction, which is, now this is going to be example custom move turtle, and this is my new package. Now this is move turtle, and this is also the main function. Okay, and let's do it a bit faster. So we're going to call this callback every 1 second. Okay, let's see what happens. I'm going back to this directory, and let's build again. So this is colcon build symlink install. Okay, everything seems to be okay. And now let's try to execute it. ROS2 run, and this is the name of the package. From my new package. Sorry. My new package, and then okay, because we are trying to print the message, and this is not the right data type. It doesn't matter. This was only if it was possible, but if it's not possible, let's just delete that instruction and let's try to run it again. And I'm going to stop the draw square. Okay, and it's not doing anything. The turtle is not doing anything, but at least we don't have any error. If I open RQT graph again, I'm going to open here. Okay, you can see that they are exchanging information, but nothing is going on because this one is just publishing an empty message, so nothing is going on, but we are exchanging information, everything is okay. Now let's add something here in the message so we are able to move the turtle and to make the turtle do something. Now let's see exactly what goes here. Let's see exactly this data type. So I'm going to do something which is ROS2 interface show, and I'm going to specify this data type over here, which is geometry messages message twist. Okay. Okay, the first character, okay, it's not correct. Let me enlarge it a bit. So this data type over here is comprised of two objects, both of them of type vector3. One of them is called linear and the other one is called angular, and both of them have these three parameters, right? X, Y, and Z. So we're going to do something like this. Message linear X equal to something, and then the same but with angular. Okay, and let's just write some random information here and let's see what happens. I'm going to stop it and I'm going to run it again. Oh, because it needs to be a float, so we need to say something like this. Okay, everything's okay now. And if we go here, you can see that now the turtle is doing something, right? It's moving. It's doing something. So I'm going to stop it, and I'm going to stop this node too, so we can just erase all this trajectory over here. I'm going to do something like this. Okay, and I'm going to execute it again. Now let's go back to Visual Studio Code and let's make the turtle do something a bit more fun. Let's make the turtle to describe a random walk, right? Let's just import another library, which is random. And now let's make each one of these parameters over here to be our random value between -1 and 1. And let's see what happens. So if I'm not mistaken, this is something like this. Let's make sure. This is between 0 and 1. So let's make it between -1 and 1. Perhaps if we do something like this, it's going to be a bit better. Uniform -1, 1. Okay. Okay, and now if I save and I execute the same node again, I'm going to close this terminal. You can see that now the turtle is moving and is describing a random trajectory. Yeah, seems a bit more fun. Let's do it a bit more aggressive, right? Because it's moving very slowly. Well, it's a turtle. It's a turtle. That's why it's moving so slowly. But let's make it a bit more fun. Let's make it between -3 and 3. I could have multiplied by 3 here and it was going to be the same, but it doesn't matter. Now it's ready. Okay. This is a bit more fun, huh? So yeah, seems everything is working well. We are able to move the turtle. Now it's describing a bit of a random walk. And I think it's much more cool to see the turtle do something like this, right? Because the square was very boring, But now this turtle is something like an artist, right? It's describing a very random trajectory. And yeah. So this is going to be all for this course. This is exactly how you can take your first steps in ROS2, and this is a very good way to get started in robotics. And yeah, this is going to be all for today. Let me know what you think of this video in the comments below, and see you on my next video. Let me give you a very quick introduction about services, in what situations we are going to use services in order to exchange data between nodes. I think a very good way to understand services is understanding what are the limitations of working with topics. Remember, in our previous lesson we were using topics in order to exchange data between nodes, and we had publishers which were publishing data into a topic, and then we had subscribers which were subscribed to the topic and they were consuming data from that topic. So this is a very useful type of communication, and it fits very well different use cases, but not all use cases. For example, every time we need to send a continuous flow of information, right? Something like this, something continuous. And also, if you notice, the information flows always in one direction, right? It goes from the publisher to the subscriber, but the subscriber does not get anything back to the publisher, right? We don't have a response from the subscriber to the publisher. So this is a very interesting way of communication. It's a very useful way of communication, but it doesn't fit very well absolutely every single use case, right? There are many other situations in which we will prefer something like this. If we use services, we are going to have a client and a server, and the client is going to make a request to the server, and the server is going to return a response. So it's a very event-based communication, right? The client is going to make a request, a very specific request, and the server is going to produce a very specific response. And there are many situations which are much better addressed by using a model like this, right? For example, if we want to know something specific that's going on here, right? Something specific, some information which is here in this node, we may make a request and we receive the information from the server, right? That could be a very specific use case. Or for example, if we want to change the settings of an application or something like that, every single use case that requires like a one-time only type of communication, and that we need a response back, right? So this is why we are going to use services. And in the case of services, for every service we're going to have only one server, but we could have many clients making requests to that server. Now let me show you some very specific examples, because this is going to be much better and much easier to understand with some specific examples. Let's open a terminal and let's run the Turtle Sim node program. Okay, now let's open another terminal and I'm going to run service list. This is a list of all the services which are currently available, right? So you can see that we have many services related to the turtle sim node. I'm going to show you only a few of them. For example, we have these two services over here, which are a way to teleport the turtle to a very specific location, right? Remember in the previous video, I showed you that if we run ROS2 turtle sim and then draw square, if we run this node over here, we are going to make the turtle to describe a square. But another way to control the turtle could be to tell the turtle where exactly to move next. And in order to do so, it's much better to do it with a service, because we don't need to supply data continuously. No, if we want the turtle to move to a very specific location, we can just tell the turtle, please move to this very specific location, and that's it. So let's see how to do that. I'm going to inspect a bit more this service we have over here, and I'm going to run ROS2 interface. No, sorry. First, I'm going to run ROS2 service type teleport absolute. Okay, and this tells me the type of data that is being sent over here, right? This type of data over here. So now I'm going to take this type of data and I'm going to run interface show, and I'm going to input this over here. I want to make this larger, and this one I'm going to make it over here. Okay. And you can see, I'm going to leave it always on top. You can see that it receives data like this, right? An XY position and a theta, right? So we're going to tell the turtle what's going to be its next X and Y position, and the theta is going to be the angle, right? Because you can see that the turtle is not only in a very specific location, but it's also moving in a very specific direction, right? The orientation is also important. So this is the data type we have over here. So now let's run ROS2 service call. We're going to call this service over here, and we're going to input this data type, and then let's input the data as a dictionary. I'm going to do something like this because it's going to make it much easier. So this is how we need to supply the data. This is going to be X. Let's make this a bit larger like this. X, then Y, and then theta. Okay, so let's move the turtle to the position 1, and theta, let's make it a value of 1 as well. It doesn't matter, this is only an example. And please notice that the data, all these values are float numbers, so we need to specify them like this, 1.0, 1.0 and 1.0, right? Because if we input these values as integers, we may have issues. So I'm going to do something like this, and let's see what happens. I need to do something else. I also need to input brackets over here and over here. Okay, because this is a dictionary, but we input the data like this. Okay, let's see what happens. You can see that we moved the turtle into the position 1, 1, and also the orientation changed, right? Let's clear everything over here. Now let's do it again, but let's do it in a different position. Let's do it to the theta 5.0 and Y equal to 10 and X equal to, I don't know, 3.7, whatever. You can see that the turtle has moved again in the XY position, and it also changed the orientation again. So this is a very specific example, and in this case we are not continuously sending data, but we have just sent data once. Now let me show you another example. I'm going to terminate the turtle sim node, and now I'm going to run ROS2 run the demo packages, demo nodes cpp, and from here I'm going to run this server over here, add to ints server. Okay, now I open another terminal. I'm going to run ROS2 services list, service list, and I get all these services over here. I'm going to use this one, so ROS2 service type, and I get this interface over here. So I'm going to execute ROS2 interface show. Okay, and you can see that in this case we have two values over here, A and B. We also have these three dashes, but now we have more information after these dashes, and this is the sum, right? So this is an example of a service in which we will have a response after we make a request, right? We are going to submit two values, A and B, and we're going to receive the sum between A and B. We have all the input parameters over here, then we have the dashes, and then we have the response, right? So let's call this other service and let's see how it works, and let's see if it works. So ROS2 service call, the service was, let's do it as like this, something like this. Okay, let's over here, right? Call, and then the interface, and then the data. In this case is A and B. So let's do something like this. A equal to 8. This is an integer. Okay, important. This is an integer, so only 8. And then B, this is going to be equal to, oh no, 2. Let's input this over here, and we get the response sum equal to 10, right? The sum between A and B. If we input something like -2 and 5, the response is equal to 3, right? Because 5 minus 2 equal to 3. So everything is working properly, and this is only an example of how another service works, and this is a very specific type of service in which we do have a response, right? So I show you two different services. In one of them we had an empty response, and then in another service we have a non-empty response. Now let's go to Visual Studio. I'm going to continue working in the same project we started in the previous video, where we were trying to control a turtle using a file like this, right? move_turtle.py. Remember, we were making a turtle to move at random, to move randomly by calling this script over here. Let me show you again. I'm going to execute turtle sim node, and then run. This was from my new package, and then this was example move turtle, something like that. Example custom move turtle. Okay, you can see that the turtle is moving at random, right? So we are controlling the turtle's velocity, the linear and angular velocity, and every second we are making the turtle to change its velocity according to these functions over here, right? So yeah, the turtle is moving randomly. Let's continue working on the same example, and now let's incorporate a service on top of this movement in order to continue learning how to use ROS2, in order to continue having some fun and also to continue learning how ROS2 works and how we can use all these different functionalities in order to work on our projects. So let's go back here. I'm going to stop everything. Now let's try to make the turtle to teleport to a new position, right? Let's use the teleporting service and let's see how to do that. So I'm going to create a new function which is called dev call set teleport service. This is going to receive self, and it's also going to receive the parameters of the teleporting service, right? Which were x, y, and theta, right? So I'm going to input x, y, and theta. Okay. And this is going to be something like this. I'm going to create a new object which is called client, and the client is equal to self.create client teleport absolute and the name of the service, which is turtle1 teleport absolute, right? So we are going to create a new client in order to make requests to this service, teleport absolute. Let's import this service over here. This was over here, turtle sim service teleport absolute, right? This was the interface. So from turtle sim dot service import teleport absolute. Okay, and this is the service turtle1 teleport absolute. Remember, I can run it over here. Turtle1 teleport absolute, this one over here. So we're going to create a new client, and then we need to create a new request. So we're going to say something like request equal to teleport absolute dot request. Okay, then I'm going to specify the fields of the request. It's going to be x, y, and theta. So this is equal to x, y, and theta. Okay. Then I'm going to create a new object. This is going to be a future object. This is a variable name which is very commonly used in these cases, and this is going to be called client call async and request, right? So we're going to make a request, and we're going to make this request work asynchronously, right? We're going to make the request, and then we're going to move on. We're not going to wait until we have a response. This is very important to do like this, because this has to do with the way ROS2 works, right? Remember that we are creating a node over here, we are spinning the node, and by the way this spinning works, it's very important this call over here to be asynchronous, because otherwise we may have different type of issues. Now I'm going to say something like future add done callback, and I'm going to call another function which we will need to import, which is called partial, and then let's call the callback, which is going to be called set teleport. Okay, this is a function we need to import, and this is over here in func tools. Yes. Okay. Okay, this is callback set teleport. Okay. So we are making a request, and then we are calling this function over here. And this is very important, because this object over here, this is actually a future object, because we are making this request asynchronously. So we're going to return immediately. We're not going to wait until we have a response. We're going to return immediately. But After this is executed, we will in the future have a response. So we will call this callback over here in order to make sure that once we have a response, we will be able to process that response, right? This is very important. So I'm going to create a new function, which is def callback set teleport, and this is going to return this is going to receive self and the future object over here. And then the only thing we will need to do is to define a new object, which will be the response, and this is future dot result, right? Because for now, remember, the teleport service we will be using does not return anything. It has an empty response. So in our case, this is not really useful. I mean, we're not going to use it. But in our cases, if we do receive a response, then we will be able to do something with that response, right? And for now, let's leave it like this. This is like the basic functionality we need in order to make it work. Ideally, we will need to do some error handling, and we will need to do some things a bit better in order to make sure it works much more flawlessly or in order to make sure that we have a bit more information to understand what's going on and to debug all the errors and so on. But for now, in order to keep it simple, let's just leave it like this, because this is the basic functionality. The only thing we need to do now is to make a request, right? We will need to call this function, and we're going to do it over here. Remember, we are making the turtle to move at random. Let's make this turtle to teleport every once in a while. Let's make it to teleport to some random location, right? So this tutorial is obviously only for instructional purposes, right? The type of project we're working on perhaps is not really a real project, because we're just making a turtle to move randomly. But the most important thing is that we are learning how to use all these tools. So in the future, we will be able to use these tools in different type of projects, right? Now let's do something like this. We want the turtle to teleport, but we don't want to do it absolutely every single second, right? Because otherwise this is going to be like super crazy. Let's make the turtle to teleport once in a while. So let's say something like this. If random less than 0.1, right? So in 10% of cases, once every 10 cases, we are going to make the turtle to teleport. So we are going to say something like this: self.call set teleport service, and we're going to input x, y, and theta. Okay. And let's define this x, y, and theta like this. It is going to be random too. We are going to say random.uniform, and let's define the range, which is going to be between 0 and, I don't know, let's say something like 10. Something like this. Okay. So once every 10 executions, we are going to, I mean, in average, one every 10 executions, we are going to call this service over here, and we're going to make the turtle to teleport. So let's see what happens. In order to make it a bit more noticeable, let's do it a bit more frequently at first, and then we can make it a bit less frequently. So at first, let's do it in absolutely every single iteration, right? At first, we're going to do it always, and then in future cases, once we make sure everything is working properly, let's make this a bit less frequent. So I'm going to save the changes. Remember, as we have built this project using the symlink install argument, we don't need to make that a build again, right? Because this is just going to, as we have updated the file, this is just going to take the files, and we don't need to build the project again. So I'm going to clear this terminal. This is running, so the only thing I'm going to do is the same thing I executed over here. So now we will be teleporting the turtle in absolutely every single iteration. No, we will not, because we made a mistake. Object has no attribute called set teleport service. Okay. Oh, right. This should be a function like this. This is a function from this class. Okay. Let's do it again. And now you can see that at absolutely every single iteration, we are teleporting our turtle. Okay, so everything seems to be working just fine. Now let's do it again, but now a bit less frequently, because we don't want to do it absolutely every single iteration. Poor turtle, otherwise it's going to be like super DC, right? Because it's going to be teleporting all the time. So I'm going to run this again. And let's see now. Oh, I didn't save the changes. Okay, now it seems it's not teleporting. Now it's moving super smoothly. And there it teleported. Okay, let's do something else, because I want the teleportation to be a bit more realistic, right? Ideally, when the turtle teleports, we should not be seeing this drawing over here, right? Because every time it teleports, like the way teleporting works is that we should not be seeing any trajectory whatsoever, right? It should disappear in a given position and it should be reappearing again in the other position. So let's try to make this a bit more realistic. And in order to do it, I'm going to use another service. It's also a very good opportunity to get a bit more familiar with different services. So ROS2 service list. I'm going to use this service over here, which is turtle1 set pen. And using this service, we will be able to adjust the settings of the trajectory, right? The drawing. We will be able to change the color, and also we will be able to turn it on or off, right? I want to turn it off every time the turtle teleports. Okay, so this is the service we will be using. So I'm going to do the same as before. This is going to be ROS2 service type. Okay, and now let's check the interface. ROS2 interface show. Okay, so we will need to input 3 values RGB. This is going to be the color of the drawing, and then width is going to be the width, and then off is going to be a Boolean value, which is going to be either on or off, right? So we're going to either draw the trajectory or not. This is the one I'm going to use actually. Everything else is not really, I'm not really interested in. So let's do something. I'm going to get back here, and actually we are going to do exactly the same as we did over here, right? We're going to call a service, we're going to wait until it's done and everything, but we're going to do exactly the same with another service. So the only thing I'm going to do is to copy and paste these 2 functions over here, and I'm just going to change the names, right? So this is going to be called set pen service. This is going to receive now RGB with and off, right? We're not going to use all of them. We're only going to use this one over here, but let's do it right? Let's just input everything. Now this is not going to be teleport absolute. Now this is going to be set pen. And set pen, we will need to import it from TurtleSim service. So we could do something like, let's do it like this so it's a bit more clear. Set pen, okay. We could also do it like this, right? But let's make a different import over here so it's a bit more clear. Okay, then we need to set pen, turtle1, this is set pen. Set pen requests, then R be theta and off. Okay, this is going to be the same. Sorry, this is width. Then this is going to be the same. Set call over here is pen and pen. Okay, that's pretty much all. Yeah, this is exactly the same as we had before, but I just changed a few names in order to make it work with set pen. Okay, everything is ready. And now let's call it over here. So every time we are here, we're going to call this one over here. And I'm going to input. Let's do it. Yeah, let's do it over here so it's a bit more clear. Let's make the drawing to be white. So I'm going to input 255 for red, green, and blue. Then the width, I'm going to set it in 3. And then this is the parameter I'm really interested in. Off is going to be it's going to be true when we start the teleporting, and it's going to be false after. Okay, and something very important to keep in mind is that, remember, these requests over here are asynchronous, right? These are asynchronous requests. So although we are making the requests in this order, first we are turning the drawing off, then we are doing the teleporting, and then we are setting the drawing on again. The requests are made in this order. They may not be completed in the same order, right? This is something that's very important to keep in mind. So in some cases, we are going to see the turtle teleports first, and then we are setting the drawing off, right? So yeah, it may happen every once in a while, because remember, these requests are asynchronous. If this were a much more a different type of project, and we need to make sure all their requests are completed in the same order too, then we will do some things in order to make sure, right? But for the sake of this tutorial and for the sake of simplicity, let's just move on, and let's just remember that the requests are asynchronous, and in some cases things are not going to be completed in this order over here. I'm not exactly sure about the color over here, not sure if this is exactly the same color as we currently have, but let's see what happens. I'm just going to save the changes, and let's get back here and let's run it again. I'm going to run it again so we make it a bit more noticeable. So let's make it happen every single iteration to make sure it's working well. Okay, every time it teleports with this in every single iteration, it's not drawing the trajectory. Now it's a bit more realistic. This is how it usually works, right? Okay. Now the turtle is teleporting. Yeah, I like it. And this is exactly how we can create a new client, right? A new client. We have created 2 different clients. We are drawing the pen, and we are also teleporting the turtle. So these are 2 different clients for 2 different services. And now let's move on. And now the next step in this process is creating our own services, right? Because so far we have made requests to existing services, but ideally we would like to create our own services and our own servers, so we will be able to take requests from other clients, right? Let me show you how to do that. I'm going to open a terminal, and in order to create a new service, we will need to create a new package. So I'm going to my workspace, src directory, and I'm going to create a new ROS2 package like this. Create for build type, I'm going to type something like amend cmake, right? This is the type of package we need to create in order to create our custom service. Actually, this is necessary in order to create a new interface, which we will then create, we will then use in order to create a new service. Let me show you. So this is going to be called something like my new interface, something like that. And then we are going to do something like this. I'm going to build in order to make sure everything's okay. So cd over here, and then build colcon build symlink. Okay, now we have two packages. My new package, which is the package we created in our previous video, and now we also have my new interface. So let's go back to Visual Studio. I'm going to close this file over here, and you can see that now we have my new package and also my new interface. So let's do something like this. I'm going to create a new directory, which is called SRB for service, and in SRB I'm going to create a new file. Let's create a new service in order to control the randomness of our process, right? Because we are making the turtle to move randomly. Let's try to have a way to control how strong the randomness is, right? So let's create something like this: set random strength, right? I'm going to call this something like this, and then we are going to say something like this. I'm going to make the font a bit larger. Let's make it 15. Okay, so this is going to define what are all the arguments and what's the response we will get every time we interact with this service. So for now, let's just have only one argument, which is going to be a float, and this is going to be the random strength, right? Then we will have these dashes over here, and then we will not have any response, right? So this is going to be a very simple service, a very simple interface with only one input, which is this number over here. Now let's go back here, and I need to make some changes in these two files over here. So let's start in package.xml. This is very important because otherwise this is not going to work, and it's very hard to remember exactly everything we will need to type over here. So my recommendation for you, every time you create a new interface, just try to copy and paste these few instructions I'm going to tell you right now, because it's very hard to remember exactly what goes over here. So I'm going to create 3 lines. One of them is build depend, then we also have exec depend, and then member of group. So for build depend, we are going to say something like ROS2 default generators. For exec depend, we will say ROS2 default runtime, and then member of group ROS2 interface packages. And now we are going to open the CMake list, and we're going to make some changes over here. So over here, we are going to create a new find package, which is ROS2 default generators, and this will be required. Okay. And then we are going to create another instruction over here, ROS2 generate interfaces, This is the project name. And then the name of the service we created, which is set random strength. And something I forgot, this needs to be .srv. Okay. And as I mentioned, this seems a bit unusual and it seems a bit hard to understand. But yeah, just remember this is necessary every time you are creating a new interface. And in order to make sure everything's okay, let's try to build the project again. Okay, now let's try to find the interface we created. So I'm going to ROS2. If we say something like interface show, this is going to be my new interface, and then I need to source bash rc again. Okay, so this is the interface we created. Everything's okay. Remember, in my bash rc file, I added at the end the install.setup bash from my workspace. So that's why I just sourced bash rc again. Sometimes it's necessary in order to make the terminal to know where everything is located, right? This is necessary sometimes. So everything is okay, everything is working properly. We have been able to create a new interface. So now let's move on. This is the interface we are going to use in order to create our service. So now let's get back over here. I'm going to clear the terminal over here, and let's just get back to the Python file we had over here. Move turtle. Let's create a new service, and in order to do so, we are going to do it over here. Every time we create a new object of this class, we are going to say something like this: self.service equal to self create service. This is set random strength. This is going to be the name of the service, which we are going to create now. This could be any name we want, but let's say something like this: example service set random strength. Okay. And we need a callback in order to wait for requests, right? So this is going to be set random strength callback. Remember, this is a service we are creating in order to control the strength of all the randomness we have over here, right? Because so far we have this constant which we are using in order to somehow control the random numbers we are sampling for each one of our variables over here. But let's try to make it in a way that we can set it from a service, right? By using a service. So that's what we will be trying to do now. This is something we will need to create, otherwise it doesn't work. And we will do something like this. This is going to be even simpler than creating a client. You're going to see why. So this is going to receive self, also the request and the response. And this is going to be something like, oh, sorry, I need to make this import over here, otherwise it's not going to work. .srv import set random strength, okay. And then I need to import this over here. Okay. Perfect. So we are going to have a variable over here, which is something like random strength, and this is request dot random strength. Okay. And then that's pretty much all. We are also going to have a response. And let's return the response, right? Because remember, every time we are making a request to a service, we are getting a response back. It doesn't matter if it's an empty response, it doesn't matter. We still need to return something, and this is what we need to do over here. Okay. So that's pretty much all. And then let's use this variable over here. I'm going to create it over here in the constructor. This is going to be equal to 3, right? And then this is going to be something like 1. Let's do it like this. Okay. Okay, so if we do not use the service, I mean, if we do not change the value, everything is going to work exactly the same as before, right? Because we have a number 3 over here, and we are multiplying by this other thing over here, which is going to sample numbers between -1 and 1. But if we do receive a request over here, we will be changing this value. So that's pretty much all. If I'm not mistaken, this is going to work just fine. Right? You can see that creating a server is even easier than creating a new client, because in this case we have this thing over here. This is going to create this service over here. Yeah, everything seems to be working just fine. Okay, now let's see if it works. I'm going to save the changes. I'm going to save this over here. I'm going to save everything. And let's see, I'm going to run the project again just in case. I'm going to build the project again. I think it's not necessary, but let's do it again. I'm going to source bash rc again to make sure everything is okay. Okay, and now let's see what happens. So I'm going to run from my new package. This was the name. Okay, now it's running. So now it's running. Let's see what are all the services which are currently waiting for requests. So I'm going to run something like ROS2 service list. And you can see we have this over here, example service set random strength. So in order to make it more compatible with everything we created so far, let's change the name. And let's do it like this. Okay. Because it's going to use the same node we have, the same name we have over here, right? Or actually, we can do it even better, and we can just say this is name. Okay. Perfect. Let's see if it works. I'm going to stop it. I'm going to run it again, and I'm going to call service list again. Okay, now it works. So Everything seems to be working just fine. Let's see if this over here works. So I'm just going to run this again. Okay, so now it's moving according to everything we have in the file. So it's setting the velocity at random at every iteration, and 10% of the time is going to teleport, right? Exactly what we have defined in the Python file. So everything seems to be working just fine. Okay, now let's try to use this service we created. So I'm going to clear, and I'm going to say something like ROS2 service type. Let's make sure we know what's the type first. So we are here. Okay, and now okay, so this is exactly the same as we have, just to make sure and just to know for sure what exactly we will need to specify now. So we're going to say ROS2 service call. We're going to specify this name over here. This is the service we're going to call. This is the type we're going to input. And now this is exactly how it's going to work. So I'm going to say something like this. Something like this. Okay. Remember, its current value is 3, right? Let's make it a bit more intense, right? So let's make it 10. Let's see what happens. Okay, and you can see that now it moves much faster, so it seems it's working just fine. Now let's make it a bit less intense. Let's take it up to 1, and you can see that now it's moving much more slowly. I'm going to run it again so we can just, make it much more clean. So yeah, it seems it's working just fine. Now it's 1. If I make it 20, it moves much more aggressively. If I make it 3.5, it's over there. Okay, now it's moving kind of with the same speed as it was moving at the beginning. So yeah, 0.4, and now it's moving very slowly. So yeah, everything seems to be working just fine. So this is exactly how we can use ROS2 services, and this is how we can create a new client, how we can create a new server, and this is how we can use it in a very specific project. This is going to be all for today, and see you on my next video. Now let's move on with parameters. This is a very important functionality of ROS2, and let me explain a bit why this is so important and how we're going to use it in our projects. So before we start with today's tutorial, let me show you these 3 pages over here. This is part of the ROS2 official documentation, and these are some pages which are going to help you a lot to further understand parameters. This one over here about basic concepts, then this or one over here with a few examples so you can see in practice how this works, and then we also have this other page about using parameters in a class in Python, and this is a very specific implementation on how to use parameters in Python. Now let's move on, and let me show you why parameters is such an important thing in ROS2. And in order to explain it, let me get back to Visual Studio Code, and let me get back to this class in which we have been working on for the last few lessons. Remember, from one of my previous lessons, we created this service over here in order to set the value of one of our variables, right? We had this variable over here, random strength, and we created this service in order to set its value. So this was functional for sure, it worked very well, and this is one of the ways to do it, right? Every time we have a variable and we want to be able to set its value, from a separate process, right, from outside the node, then this is something we could do, right? We could create a service and everything we did in my previous tutorial. But there are a few disadvantages with following this approach. So, for example, here we had a service in order to set the value. What are we going to do if we wanna get the value, if we wanna retrieve its current value, right? Because that could be a very valid use case. Perhaps there's someone who wants to know what is the current value of the variable over here. What are we going to do? Are we going to create a new service to get the value of our variable? Okay, perhaps let's assume we do something like that. So for every variable we want to control, we're going to create two services, one of them to set the value and the other one to get the value. And I guess doing something like that works well and it's manageable if we have only one variable. But what's going to happen if we want to repeat the same process for many variables throughout our code, right? At some point it's going to be a bit hard to manage because we're going to have a lot of services. Remember, for each one of these services, most likely we are going to create our custom interface in order to work with this service. So it's going to be very hard to manage. It's going to be a lot of work and it's definitely not the best way to do it, right? So this is one of the disadvantages with doing exactly what we did in one of my previous tutorials. And then another disadvantage, which is very important, has to do with separation of concerns, right? Ideally, we would like to have a way to separate everything that has to do with the functionality of our code with all the parameters we have in the code, right? Ideally, we would like to abstract ourselves and to separate those two things, because currently, if we follow this approach over here, everything is like mixed together, right? Everything is like part of the same thing. But ideally, we would like to separate these two concerns so everything is a bit better in various ways, right? I'm going to show you a few examples later today. So long story short, the way we did in our previous tutorial works very well if it's only one variable, but at some point, oh no, we want a better way to do it, and that's exactly what parameters are for. Let me show you a few examples of how using parameters is going to help us to overcome the challenges I just mentioned in the code over here. I'm going to make this a bit larger, like this. Okay. So let's use the TurtleSim node package. I'm going to call ROS2, run TurtleSim, and then TurtleSim node. Okay, and then I'm going to open another terminal. I'm going to type ROS2 param list. And this is going to give me a list of all the parameters for all the nodes which are currently running. In this case, it's only the TurtleSim node. So let me show you something else. You can see we have all these parameters over here. I'm going to call ROS2 param get, then the node name, which is this one over here, and then the parameter name. I'm going to use this one over here. And I get this value. The iter value is 255. I'm going to do the same for background G. We get 86, and for background red, we get 69. You can see these three parameters over here represent the color of the background of this simulation we have over here. So this parameter over here is very important, and this is a very easy way to get the current value of a given parameter. So let me show you. I'm going to make this a bit larger. What if we want to change the value? If we want to change the value of the background, we could do something like ROS2 param set. We are going to call this thing over here. Then, for example, we could change the value of the red component. And then we could set it in something like 255. And you can see that immediately we have changed the background to a different color. Right now, BGR, we have 255, 86, and 255. If we change the blue component to 0, we're going to have something like orange. And if we change the green component to 0 as well, we are going to have something that's 100% red, right? So this is a very easy way to set the current value of a given parameter, right? So this is the way to use parameters in order to get the value and in order to set the value of the different parameters in your code. Now let me show you something else, because you can see that we have many parameters over here, and we also have a way to dump the value of all the different parameters. So I'm going to execute ROS2 param dump and then turtle sim something like this. Okay, and you can see that we are printing this thing over here, which is a dump of all the values of the turtle sim node package, right? So I'm going to copy and paste it in something like this. Let's leave this open for now. I'm going to save it over here. Oh. Something like this. Not completely sure about the structure. We may need to make a very small change, but let's try and let's see if it works. Sim parameters.yaml. Okay, now let's try to load these parameters, right? I'm going to clear and I'm going to say something like ROS2 param load turtle sim and then the location of the file, desktop, and then example turtle sim parameters yaml. Let's see if it works. Okay, perhaps we need to do it a bit differently. Perhaps we need to copy the entire thing. Let's try now. Yes. So we have loaded all the parameters we dumped over there, right? Now, if we want to make a change, we can just go ahead and change this file over here, right? I'm going to make this change over here. I'm going to set the blue component to 255 and the green component to 0 and the red component to 0 as well. I save the changes, I load the file again. And you can see that this is another way in which we can just change many parameters at the same time, right? So this is a very interesting functionality as well. Not only because we can change many parameters simultaneously, but also now we have abstracted ourselves and now we have the node in one part and we have the parameters as a separate thing, right? So this is like an independent file we could potentially share with other people. If we work collaboratively with other people, this is something we can just provide like an independent file. We could reach out to our team members and we could tell them, hey, I tried this very specific configuration of parameters and I tried in one of our robots and this is what happened. Take a look at what happened. This is a file with all the parameters, right? So this is a much better way to communicate some results, to experiment, to document our processes, right? Because now we have a very specific file with all the configuration of all the different parameters. So this is going to be a very useful thing for sure. And now let's go back to Visual Studio Code, and now that we know so much about parameters, let's do this thing over here a bit better, right? Let's create parameters in order to control the value of this variable over here, and also let's go through this class and let's see if we can create other parameters so we can do a much better handling of everything that happens here in this code. Okay, so the first thing we're going to do is to create a new parameter for the random strength. So let's do something. I'm going to get back here and I'm going to type random strength only to remember all the parameters we are going to create. So this is one of them. Then perhaps we want to create another parameter for this value over here, right? This thing over here, if you remember, this was the teleportation rate. This was how often we were running this part over here, which was taking care of the teleportation, right? So let's create another parameter, which is teleport rate. And then let's continue going through it. Perhaps we want to create another parameter for this function over here. Remember, this is the probability function we are using in order to sample values which we then multiply by the random strength. But this could be another parameter too. Perhaps the user wants to use a uniform distribution, or perhaps they want to use a different type of probability distribution. So let's create it as another parameter over here. I'm going to type something like random distribution, something like that. Then let's continue. And then perhaps we could have another parameter in order to control if we are going to turn the drawing off or not every time we teleport, right? That perhaps may be a different use case. Perhaps that's something the user wants to control. I don't know. So let's create another parameter for the teleport drawing off. Okay, I like these parameters because we have a bit of everything. We have float numbers, we also have a boolean value over here, we're going to have some strings, so we have a bit of everything. Now let's see how we can make it work. The first thing I'm going to do is to remove everything that has to do with what we created over here regarding the service, right? So I'm going to remove this function over here. And I'm also going to remove this other function over here. Okay, so the first thing we're going to do is to declare all these parameters, and this is what I'm going to do. I'm going to call self.declare parameter, and this is going to be this parameter over here, the random strength, and the first value, the starting value is going to be 3.0. We do not need to specify this a float value because this is going to realize by itself, right? Whatever we put over here is going to be the type of this variable. So this is going to be a float number, and let's continue. Then we are going to create another parameter for the teleportation rate. We're going to set it like this. And then the first value, the default value is going to be 0.1, right? Which is the value we currently have over here. Let's create another parameter for the random distribution. And let's set it in uniform. And then let's see how to do this, because we cannot set any value we want, right? We are going to choose between a few probability distributions, and let's see how to do that in a few minutes. But for now, let's leave it like this. Now I'm going to declare another parameter, which is teleport drawing off, and this is going to be true at first. Okay, now let's see how to make it work with all the parameters we have over here. The first thing we're going to do is to use the random strength. So I'm going to go back here to this callback. This is where we are using the random strength, but now it's going to be one of our parameters, right? So this is what we are going to do. We are going to say that random strength is equal to self get parameter random strength dot value. Okay, this is how we're going to get the value of random strength at every single time, right? Every time we call this callback, we are going to get the current value of random strength. And that's pretty much all. We do not have this value anywhere else, if I'm not mistaken. No, okay, so that's pretty much all for the random strength. Now let's do the same for the teleportation rate. I'm going to do something like this, teleport rate. Okay, and this is going to be lesser than teleport rate. Okay, then let's move on over here. I'm going to leave this one for the end because it is a bit more complex. The teleportation drawing off, this is going to be, let's copy the same instruction over here. Teleport drawing off teleport drawing off, and then we're going to say something like this: if teleport drawing off, then, and if not, we're not going to turn it off, right? And we don't need to run this instruction over here if we didn't run the other instructions. So I'm going to say something like this. Okay, so if we are turning the drawing off, then we are going to execute these two instructions, and if we are not, then we are not going to execute either of them, right? Because it doesn't make sense. And now let's move on. This is the other variable, and then the only one we have left is the random distribution. In this case, we will need to do something a bit more complex, because now we cannot let the user to just type anything they want, but we will need to make them select from a few possible options, right? So let's see how to do that. I'm going to fix this thing over here, and then let's get back over here and let's go to the random Python library documentation, and let's see exactly what are the different probability distributions we have available, and let's see which one we want to use in this project. So this is the one we are currently using, which is the uniform distribution. You can see we have many distributions over here. We could potentially use all of them, but let's keep it simple, and we can use this one over here, the normal distribution. So let's just make the user select one of these two, either uniform or normal. I'm going to create another function which is going to be called every time we want to validate the parameters. This is going to be called validate params. This is going to receive self and also the parameters, right? I'm going to call it params. And I'm going to iterate in all the parameters, so for param in params. And let's just validate this one over here, because all the other parameters can be pretty much anything they want. I mean, as long as they are the right type, this can be either true or false, and this can be either like any float number will be okay over here and over here. So this is the only one we are going to verify. This is the only one we're going to validate. So this is how we're going to do. If param name equal to this one over here, random distribution. In order to make it a bit more clear, we can make it like random probability distribution, right? If this is the parameter, right? Remember, we are iterating in all the possible parameters over here. And if we are here, then let's verify, and param value is not, actually not in either uniform or normal, then we are going to return something like this: set parameter results successful false, and then reason okay, something like this. Okay, it's only an example, so let's leave it like this. And then this is an import we will need to make, because otherwise it's not going to work. And we will need to import from RCL interfaces messages import set parameters result. Okay, and let's add this dependency over here to the package XML file, because otherwise it's not going to work. Okay, save the changes and let's get back here. Yes, this should work just fine. It's highlighted for some reason, but if I'm not mistaken, this should work just fine. So that's pretty much all. This is how we're going to validate that the user has input the right parameters. And obviously we will need to return true in any other case, right? Okay. Okay, perfect. So this is the function we're going to execute every time we want to validate these parameters. And exactly how we're going to execute this function, we will need to create a callback, which is going to be executed every time the user uses the set instruction, right? Every time the user tries to set the value, then we are going to execute this function over here to make sure all the parameters which are being set properly, right? And the values are within the possible values we have specified over here. So I'm going to make another callback, which is going to be self.add on set parameters callback. We're going to call self.validate params. Okay, that's pretty much all. So every time we are trying to set the parameters, we're going to have this callback over here, which is going to be listening to those events, and we're going to trigger this function, and this is going to take care of making sure we are not accepting the set instruction if not complies, if the instruction does not comply with this thing over here, right? It's very important. And then obviously we will need to create the function that either selects one of these two values over here, right? So I'm going to create another function, which is sample. And this is going to receive two parameters, A and B, and also the probability distribution. Something like this. So if probability distribution equal to uniform, then return A and B. Okay. Else let's do it right. Let's say elif this is going to be random.gauss, and in this case these parameters, this is mu and this is sigma. This is a normal distribution which is centered in 0. Let's remember how this looks like. We have something like this which is centered in 0, and we will need to make it centered in the center of the interval the user inputs, right? In this case it's -1, 1, so it's also centered in 0, but just in case, let's make it a bit more generic. So this is going to be something like mu. Yeah, mu and sigma. Let's use only mu, and this is going to be A plus B divided by 2. Okay. So we make sure that this is centered in the center of this interval over here. Okay. And something else we will need to do, we will need to clip this value, right? Because remember, the normal distribution can sample pretty much anything from -infinity to +infinity. So let's make sure we are within the interval, otherwise it's not going to make sense. There's another way to do it using numpy, if I'm not mistaken, the numpy.clip function, but let's do it like this because it's very simple. So I'm just going to do something like if this is lesser than A, Then I'm gonna make this equal to float a, because I'm going to input a and b as integers, so it's much better to do it like this. And then if this is greater than b, then the same thing over here, but with b. Okay. Yeah, something like this is going to work just fine, if I'm not mistaken. Now let's continue. The only thing we need to do is to return this value over here. Okay. And if the user has not input either uniform or normal, then this is going to throw a huge exception. But let's just leave it like this for now, so we keep it simple. But this is going to take care of the basic functionality. Everything's okay. Let's continue. The only thing we need to do is to go here and to replace this part over here with self.sample, the interval which is -1, 1, and then the probability distribution, which is this one over here. And then the only thing we need to do is to replace this value over here, and that's it. Then we go here and we also need to change this value, right? So this is 0 and 10. And that's pretty much all. Yeah, if I'm not mistaken, something like this is going to work just fine, but we need to try it in order to make sure, right? We need to execute it in order to be 100% sure. Let's scroll up. I see I still have this error over here, but let's see what happens. I'm just going to execute it. So let's go here. I'm going to run the turtle sim package, the turtle sim node program, turtle sim node. Okay. And now let's run our program. And then this one over here. I think I made a mistake and this is, yeah. Okay, I need to change it over here as well. And let's see now if it works. Okay. Okay, it seems it's working. And now let's print all the parameters. ROS2 param list. You can see that these are all the parameters for this node over here for our code. So everything seems to be just fine. Yeah, 1, 2, 3, 4. Now let's get only a few of them, or perhaps we can make a dump and we can see how they look like. ROS2 param dump. Okay, 3.0 through 0.1 and false. Okay, so now let's go here. And I'm going to set, perhaps we can start changing the probability distribution, and let's set it in random. Let's see if it works. ROS2 param set. Then this is let's remember this one over here. Let's try to see if the validation works. So I'm going to input something that doesn't make sense and it doesn't work. Okay, so everything's okay. Now let's try to set it in normal. Parameter successful. I don't think, oh, we have a problem. No. It seems we need to input sigma as well. So let's go back here. And let's make it a standard normal distribution. So let's make it equal to 1.0. Actually, it's not standard because it's not centered in 0. But anyway, let's make sigma equal to 1.0. Save the changes and let's run it again. Okay, let's go back here. Okay, we are not going to see a huge difference because it's pretty much, it's sampling numbers at random, so it's going to look pretty much the same. Now let's set another parameter. Perhaps the teleportation rate. Let's set it in 0.99. And now it teleports every single time. Okay, let's do it with the teleport drawing off. Let's set it in false, and I'm going to reset this node over here. You can see that now it teleports, but it draws all the trajectories between the nodes, between the positions. Okay, now let's see if the load works. I'm just going to save it like params tutorial config YAML, and I'm just going to 0.5. This one, let's set it in true. Let's set the random strength in 15, and this is normal. Okay, then I'm going to okay, everything is working just fine. Something that's very interesting is that you can see that we are setting each one of these parameters one at the time. So technically, if we try to do something like this, I'm going to slow it down a bit because otherwise it's distracting. Okay, if we try to do something like this, it's not going to set this parameter. It failed. You can see this one over here. This one over here, it failed, but all the other parameters were set successfully. That's a very important detail that we need to keep in mind. Now let me show you something else that's also a very important functionality, because if we terminate this program over here and we start it again, you can see that all the parameters have been reset to their default values, right? Everything has been reset to their default values like this. But there is a way to execute the script taking a file like this as input, right? We are going to load all these parameters when we execute the node, right? That's a very important thing to do. So I'm going to run this command over here. Right, we're going to run the package, but we're going to do it with this argument over here, ROS2 and then params file, and I'm going to input the location of the file, which is this one over here. And if we do it like this, we need to make sure that all these parameters make sense, right? In this case, this one over here fails, so we are not able to load the file. So I'm going to do it again. I'm going to set it in normal, which is one of the possible values. And you can see that now everything's okay. We are starting from these values over here. Now I'm going to set this number in 10. I'm going to stop it, running again with the same argument over here. And you can see that it loads the new values and everything's okay. So this is going to be all for this tutorial. This is exactly how we can use ROS2 parameters in our projects, and let's move on to the next lesson. Now let's move on to actions. This is a very interesting way of communication between nodes, and let's try to understand in which situations we are going to use actions instead of using services or topics. And let's try to understand what actions are for, and perhaps a very good way to do it would be understanding what are the limitations of working with services. Remember from our previous lesson we discussed services and we mentioned this was a client-server type of relationship and it was like an event-based type of communication. So the client made a request, a very specific request, and the server replied with a very specific response. And this form of communication fits very well many use cases, but there are some cases in which it's much better to address them with a different type of structure. Let me give you an example. Let's assume we have a robot, a physical robot, something like this, and we would like the robot to move in a specific trajectory, right? So perhaps we can use something like a service and we can tell the robot, please move to this very specific XY position, right? Perhaps we want to use something like a service in order to instruct the robot to do that, right? If we were to use a service in order to accomplish that goal, there are two different problems which are very important and they are not very well addressed using services. The first one has to do with if we talk about a physical movement, right, a trajectory, that may take a very long time, right? And when we use services, we wanna do like a very quick communication, right? It's like I send you a request and you give me back a response. It's not the idea to spend hours waiting for the response, right? And who knows how much time it's going to take to a robot to complete the trajectory, right? So that's the first problem we have if we were to use services in order to do something like this. Then the second problem we have if we were to use services in order to complete this task has to do with different challenges we have every time we work with hardware and with physical components, right? Because this is very hard to understand for people who are used to work with software, but once you work with physical hardware, then you realize that many things can go wrong at every single time. For example, if we instruct the robot to do a specific trajectory, to complete a specific trajectory, and the robot spends hours and hours and hours in that process and they never get back to us telling us that they either that they either succeed or failed, and we will have absolutely no idea on what's going on, and perhaps something happened with their battery level, and the robot is not able to move the wheels at all, right? So ideally, we want to have some feedback during the process because we want to understand exactly what's going on, right? A service type of communication does not address very well some type of tasks. So for those tasks, we are going to use actions, right? So if I go to the ROS2 official documentation, you can see that says actions are one of the communication types in ROS2 and are intended for long-running tasks. So every time you want to use a service, every time you have like a service type of communication, like an event-based type of communication, but you realize that this is going to be a long-running task, that this may be a long-running task, then you may want to use actions instead of services, right? You may want to use an action instead of using a service. And let me show you this picture over here. I'm gonna try to make it a bit larger so you can see it a bit better. You can see that the structure of an action is not really like a new type of structure, but actually is comprised of two different services and one topic, right? So every time we work with an action, one action is comprised of two services and one topic, right? That's very important. And let me show you how it works. So this is also a client-server type of relationship. And in this case, the client is going to send a request of a very specific goal. And then the server, the first thing they're going to do is to respond, telling us if they accept or reject the goal. And then we have another service over here which has to do with requesting the result of the task, right? Because perhaps the robot was able to succeed in completing that task and perhaps they failed, right? So we want to understand what happened, and we have a separate service for addressing the result of the task. And then we also have this topic over here, which is for providing feedback, right? And this is where I think actions are so meaningful and so valuable, because remember, so many things can go wrong during this process of accomplishing the task that we definitely want to have some information on what's going on. And this is where the robot is going to tell us what's going on, right? It's going to provide some feedback of what's going on during the process of accomplishing that goal. So this is a very high level understanding of how actions work in ROS2. And now let me show you a few examples. I'm going to show you an example from the TurtleSim node package. So I'm going to open a terminal and I'm going to type ROS2 ROS2 run TurtleSim node. Okay, so we are running the TurtleSim node package, and now I'm going to open another terminal, and this is going to give me a list of all the actions which are currently waiting for requests. Actually, for all the servers of all the actions which are currently active, right? Which are currently waiting for incoming requests. And you can see we have only one, which is turtle1 rotate absolute. Let me run the same command, but now I'm going to do it with this other argument over here. This is going to tell me the type of all the actions, right? In this case, we have only one. And it's going to tell me this type over here. So I'm going to copy and paste this type in this other command, because let's see exactly what this interface over here, what this is about. And you can see we have these three values: the desired heading in radians, the angular displacement in radians to the starting position, and the remaining rotation in radians, right? And you can see we have these dashes over here. So let me open. So every time we have the interface for an action, we are going to have a structure like this. The first part is going to be the goal, right? The goal we are trying to accomplish. This is going to tell us what's the type of the goal, right? The data type. So if it's a float, or if it's an int, or if it's whatever, the data type of the very specific goal we are trying to accomplish. Then we're going to have these three dashes. And then we are going to have the data type of the result, right? The same thing, if it's a float or if it's an integer or whatever. This is going to be the result. And then we are going to have, again, three dashes, and we're going to have the feedback, right? The data type of the feedback, right? Because remember how actions work. We are going to have the goal, we're going to have the result, and also the feedback. So this is exactly how the interfaces are going to look like in the case of actions. So I'm going to type ROS2 action send goal, and then I'm going to specify what's the action. In this case is this one over here, and the type, and then I'm going to specify the goal. Let's get back here. So this is going to be the first element, which is theta, and it's a float number. So I'm going to create something like this, a dictionary with only one element, which is theta, and this theta is going to be a float number. So I'm going to make it equal to something like 1.0, right? Let's just use this number for now, and let's see what happens. And you can see that the turtle has moved its direction, right? I'm going to do it again. Now I'm going to say this is 2.0. Please mind the turtle over here. And you can see that every time I instruct the robot to rotate, the robot rotates a given direction, right? So remember what this represents. We are sending the goal, and the goal is going to be the desired heading in radians. So you can see that the turtle is not only in a given specific position, but is also facing a very specific direction, right? And every time we are using this action, we are rotating the turtle and we are specifying a new direction, right? So the goal we specify over here, the theta value, is the new direction in which we want to orientate the turtle, right? So that's what the goal represents. it's the new angle in radians, right? So in this case it's 2.0. If I do it again, 3.0, and the result is exactly how much it had to rotate in order to accomplish that goal, right? You can see it's from the description over here, it's the angular displacement in radians to the starting position. Currently the position is 3.0, so if I send the goal again with the same goal 3.0, then delta is going to be 0, right? Because it didn't move at all. It already started in this position. If delta is 3.5, then, sorry, if theta is 3.5, then delta is going to be around 0.5, right? Which is how much it had to rotate. Now, I can run the command again, but this time I can do it with this other argument over here, which is feedback. And if I do it, this is going to not only tell me the same information regarding the goal and the angular displacement in radians to the starting position, but it's also going to provide feedback of what happens during that process, right? So in this case, I'm going to do something like this. I'm going to specify the goal is 0. And you can see that the turtle is reorientating itself, right? It's moving, it's rotating. And not only we have the result over here, but we also got all this feedback of what happened during that process, right? So I'm going to do it again, and now it is going to be something like 4, right? So you can see that it's rotating. We have all the information over here, which is how much we have left, how much rotation we have left at every single time, right? So this is very valuable. Remember, every time we work in the physical world, we will have absolutely no idea what's going on once we instruct the robot to do something. So imagine that we are instructing the robot to complete a given trajectory, to rotate, to do something. We definitely want to have some information on what's going on during that process, because perhaps the robot is, I don't know, moving faster than expected, or perhaps it's not moving as fast as expected, or perhaps it's not moving at all, right? So we definitely want to have some information on what's going on during that process. This is very important in some cases, right? For some type of actions, this is very important. So this is only an example, so it's a bit more clear on how actions work in ROS2. And now let's move to Python and let's try to write a client and a server in order to continue working with actions and in order to understand how we can use them in our projects. Now let's go to Visual Studio, and I'm gonna continue working on the same workspace where we have been working in the previous lessons. You can see that this is the interface we created in the lesson about services, right? Set random strength.srb, and then this is the package where we have been working so far, right? My new package. This is where we have movturtle.py. Now we're going to continue working on the same workspace, and the first thing I'm gonna do is to create a new interface, because I'm going to create a new action server, and in order to do so I'm gonna use a custom interface, right? I'm going to show you how to create a server which is very similar to the one we have here in the ROS2 official documentation. You can see this article says creating an action server and client with Python, and if I move here to writing an action server, we have an example, and I'm going to show you how to create something similar, right? I think the best way of using actions is with real robots, right? With physical robots. So in a future tutorials, I'm going to show you how to create an action server in order to control a robot like this. We're going to make this robot to accomplish a very specific task, right? In a future tutorial, I'm going to show you how to use actions with a robot. But for now, in order to keep it simple, let's just do something similar as we have over here, because this is going to show us how to work with actions, right? How to create a server and how to create a client. And it's very important we familiarize ourselves with how to create these objects, right? So let's do something similar as we have over here. And you can see that in this example, the action server creates some sort of Fibonacci sequence, right? The user specifies the goal. The goal is like the order of the Fibonacci sequence, and then this thing over here computes all the numbers of the sequence up to that given point, right? You can see the interface over here is action, tutorials, interfaces, action, and then Fibonacci. So if I open a terminal and I do something like ROS2, interface show, and then I input action, tutorials, interfaces, action, Fibonacci. You can see that this is the interface of the action in this example over here, right? The goal is the order of the Fibonacci sequence, then the result is the entire sequence up to that order, and then the feedback will be all the sequence which was built during the process. So this is a very interesting example. Let's do something similar, but let's use a different sequence, right? Only to have a bit more fun. So I have been exploring this page over here in Wikipedia of different type of integer sequences. You can see Fibonacci is over here, and we have many sequences. Let's do something like this one, right? The factorial sequence. So I'm going to create an action server which is going to compute the factorial of a given number, and it's also going to compute all the sequence up to that given factorial number, right? Let me show you. So the first thing I'm going to do is to create a new interface. So in my new interface, I'm going to create a new directory, which is going to be action, and then within action, I'm going to create a new file, which is something like factorial. This is going to be the name of the interface, and this is going to be .action. Okay, so remember we need 3 fields, right? We are going to use 3 different data types, and they have to be separated by these 3 dashes over here. This one over here is the goal, then the result, and then the feedback. So I'm going to do something like this. The goal is going to be an integer in 64, and this is n, right? This is how I'm going to call the number the user is going to input, and we're going to compute the factorial of this number over here. Then the result will be also in 64, and this is going to be n factorial, right? It's going to be the factorial of this number over here. And then the feedback will be int 64, a list, right? It's going to be a sequence. And let's call this variable something like sequence factorial from 1 to n. Right? And this is going to be a list of all the factorial numbers from 1 up to the number the user is going to input over here, right? The way we are going to compute the factorial of a given number is just multiplying all the integers from 1 up to that number. So for example, if we want to compute the factorial of 10, we are going to do something like 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 and times 10. Okay, and this is the factorial of 10, right? This is equal to this is equal to 10 factorial. Yeah, I wasn't sure if the calculator allowed me to do this, but yeah, I can do this. This is exactly what we are going to do. Now let's get back to Visual Studio. And remember, every time we create a new interface, a new custom interface, we need to go here to cmakelists.txt, and we need to add the new file over here, right? So we're going to say this is action, and then factorial.action. Okay, I press save, and this is exactly what we will be doing over here. So the only thing I'm going to do is to create a new terminal. I'm going to my workspace, and then I'm going to build the project to make sure everything's okay. I'm going to do it with Symlinks. Let's see what happens. Okay, just in case, I'm going to source bash rc again. And now let's try to find the interface we created. So this is ROS2 interface, show my new interface, action factorial. Okay, this is the interface we created, so everything's okay. Now let's go back to Visual Studio. I'm going to go over here to my new package. Let's continue working on my new package. This is like a package we are using in order to create all the nodes in this project. So far, let's continue. For now, let's continue working here. So I'm just going to create a new file, which is going to be new file, something like factorial action server.py. Okay, and the first thing we're going to do, I'm going to make this a bit larger. So preferences, settings, let's make it 15. Okay, so the first thing I'm going to do is to create the class. It's going to be an empty class for now, which I'm going to call factorial action server, right? This is going to inherit from the class node, and let's import the class node also, right? So this is going to be from rclpi import node, and obviously we need to import, not absolutely needed to import rclpi for now, but let's do it. Okay, so this is the class we're going to use. And now let's create the main block, the main function we are going to use in order to execute this class, right? In order to spin the class, in order to make it work. So let's do something like this. If name equal main, we are going to execute this function over here. This is a very generic instruction in order to make sure we can also use this file and run it as an executable. So I'm going to create the main function over here. I'm going to input args equal to known, and that's pretty much all. Let's see if I have an error. No, everything's okay. And then the only thing I'm going to do is to call rclpy.init args equal args. Then I'm going to create a new instance of this class over here. So this is going to be something like factorial action server, and this is factorial action server, something like this. And then the only thing I'm going to do is to spin the node, right? So rclpy.spin factorial action server. Okay, so now let's move on. Everything is ready over here. This is the basic structure of our main function. Now let's go to this class over here and let's populate this class with everything we need to do in this project. The first thing we need to do is to define the constructor, right? So this is going to be something like init. And remember, every time we create a class, we can do it like this, or we can do it a bit differently, but let's do it like this. I'm going to input the name, and this is going to be something like factorial action server node, something like this. And this is going to be the name, right? Okay. So this is going to be something like the parent class constructor. We are going to call init, and this is going to input the name. Okay, so that's pretty much all. And then we are going to create a new action server, and in order to do so, I need to import a new class, which is from rclpy import, from rclpy.action import action server. Okay, a very important class because we need to do something like this. Now we're going to define a new class member, which is action server, and this is equal to action server, and we're going to input self. And this is going to require the interface we just created, which is from my new package. No, sorry, my new interface. Dot action import factorial. Okay. And just in case, I'm going here to package XML, and I need to add this dependency, but we already have this dependency over here, my new interface, because we already used it in our previous lesson about services, so we don't need to add this dependency again. Now let's move on. Now I'm going to input factorial, and this is going to be the name of our server, which I'm going to say something like factorial for now, because let's keep it simple. And every time we execute this server, actually every time we call this server, we are going to execute this callback over here, which is execute callback. This is the function where we will be handling the entire execution of the goal, right? This is the function where we will try to accomplish the goal. So let me show you how to do that. That's pretty much all over here. Now I'm going to create this function, which is execute callback. This is going to input self and also goal handle, right? This is a very important member, which is going to contain all the needed information in order to execute the task. So let's do it one step at a time. Let's define a new variable, which is going to be the feedback. The feedback we are going to provide the user, and this is going to be factorial dot feedback. Okay. Yes. Remember, this is going to be a list of all the values up to the factorial we will need to compute, right? So this is going to be a list. For now, this is going to be a list, and remember, the first element of the list is always going to be 1, right? You can see it's from 1 to n. So from 1, if we go here to factorials, you can see that this list over here starts from 0. This is 0 factorial, this is 1 factorial. So everything is going to start here. The first number is always going to be 1. So let's get back to Visual Studio. For now, we can just define feedback dot this variable name equal to a list of only one element, which is 1, right? This is always going to be the first element in the sequence, and perhaps the only element if the user inputs n equal to 1, right? This is going to be the only element in the list. But let's handle that case now. So now let's move on to executing the task. I'm going to create something like a for loop, right? Because we're going to iterate in all the numbers from 1 up to n, j in range from 1 up to. This is going to be goal handle request n, right? Remember, n is going to be the goal, the number for which we need to compute the factorial, right? So this is going to be in goal handle dot request dot n. Now let's move on. Now it's going to be a very simple process. The only thing we need to do is something like this. So at every iteration, we will need to append. Let's do something like this. Is going to be a bit more clear. The first thing I'm going to do is to change this over here. And then instead of doing the range like this, I'm going to do it like this. Because by doing it like this, we're going to make sure we're going to execute for this amount of times. And now I'm going to multiply the value we have over here, index j, right? Because now we're going to start from j equal to 0. So this is going to be the first element, j equals to 0. And then we're going to multiply times j plus 1, right? Okay, this is going to work. If we do something like this, remember, we may need to make some small adjustments at the end, but for now I think this is going to work just fine. Okay, and now this is very important. Remember, every time we work with an action, we are actually working with two services and with one topic. And this is where we're going to publish all the feedback, right? We need to publish data into a topic. So this is what we are going to do. We are going to call goal handle publish feedback handle publish feedback, and I'm going to input this thing over here. Okay. In order to keep the suspense a bit, I'm going to make a sleep over here because it's going to help us to execute this for over here one step at a time, right? We're going to execute each iteration 1 second at the time. This is going to be very simple. Then the only thing is going to happen, this is going to be the entire execution of the task, and there will be no surprises most likely. So the only thing we need to do now is to call goal handle dot succeed, because it means we are going to succeed in the execution of the task. And then it's going to be something like result equal to factorial dot result, and then we need to call result dot, let's remember, n factorial, and this is going to be the last number, right? Okay, and that's pretty much all. This should work just fine. Let's try to see what happens. Let's try to execute it and let's see what happens. I'm going to return result. Okay, that's pretty much all. This needs to be here. Okay, so let's just execute it and let's see what happens. I'm going to save the changes, and in order to create this node, remember we need to go here to setup.py, and I'm going to create a new executable, right? So this is going to be something like example factorial action server. This is going to be my new package dot factorial action server, and then we are going to call the main function. Okay, now let's go to the terminal and let's try to build this project again. So colcon build symlink. Let's see what happens. Everything seems to be okay. The first thing we need to do is to run the node, right? So ROS2 run my new package, and then this is this one we created, example factorial action server. Okay, we have an error. Cannot import node from RCLPY. Right, because this is from RCLPY.node, import node. Okay, let's see now. Okay, everything seems to be just fine. I'm going to execute it again. And now let's see, I'm going to run ROS2 action list -t. And you can see that this is the one we are executing. And I'm going to see again what is the type. Okay, so I'm going to say something like ROS2 action send goal, the action name, which is this one over here, then the type, and then n, which is this value over here, equal to, I don't know, 5. Oh, because I need to do something like this. Okay. We are almost there. Aborted. Something happened. Error raised. Server go handle the object as an succeed. Right. Because I made a mistake and this is succeed. Like this, right? And yeah, this should work. Let's try to run it again. Two, three, four, five. Succeed. Now n factorial is 120, and over here in the server we got feedback of every single step in the process, right? The only thing we will need to adjust has to do with, remember, the interface is that the sequence factorial is from 1 to n, right? And here we are printing from 0 to n, right? Because we have this one over here. So we will need to do something in order to make it compatible. Something like this. Now this is going to be an empty list at first. If j equal to 0, we're going to append 1 always. And if not, we are going to append this value over here according to this value over there, right? So we're going to see the previous element. And then we're going to add 1 and we're going to make this multiplication over here. Let's see if it works. In factorial equal to 1, and we also got this feedback over here, so everything's okay. If we make equal to 5, everything's okay too. Now I'm going to print with feedback. Okay, yeah, it works. So all is good. Now we can move to the next part in this process, which is writing an action client, right? Let's see how to do that in Python. So I'm going to create a new file in the same package over here in my new package, and this is going to be the factorial action client.py. Okay. This is going to be very simple, very straightforward. I'm going to copy and paste some parts over here because I'm going to use them too. I'm going to copy all the imports, but now I'm not going to import the action server, but I'm going to import the action client, right? Then this is the interface, everything's okay. And I'm going to import this part over here. I'm going to copy this part over here and I'm going to paste it over here. Okay. Now this is going to be a factorial action client. Factorial action client node. And that's pretty much all. Okay. For now, that's pretty much all. And let's create the class. So this is class which inherits from node, and that's pretty much all for now. Let's just copy as well the constructor, this part over here. Now let's create a new member, which is action client. This is going to be equal to action client. We're going to input the same class, right? Self always refers to the instance of the class we have created, the instance that's executing this instruction over here. Then we are going to input the interface name, which in this case is factorial, and then this server name, which is factorial, like this. Okay. Now let's create the functions we are going to execute in this client. The first function is going to take care of sending the goal, right? And we are going to input the goal, which in this case is the n for which we will need to compute the factorial, right? So this is the first function we will need to implement, and then we are going to create 3 different callbacks, because remember, if I show you this picture again, the action is comprised of these 2 services and also this feedback over here. So we will need to create 3 callbacks. The first callback in order to listen to the response of this request over here. When we send the goal, we're going to listen to this response. So we need 1 callback for this. Then we're going to need another callback in order to listen to incoming feedback, right? Every time we receive a new feedback, we will need a callback so we can listen to that feedback. And then we will need a third callback in order to take care of this other request over here, right? So let's create 3 callbacks. The first one will be goal response callback. This is going to receive a self, and it's also going to receive a future object. Then we are going to define another function, which is get result callback, which is going to be a similar situation. And then we will have the feedback callback, which is going to receive feedback, right? And we will need to process this feedback. Okay. So let's get started over here with sending the goal. Then the first thing we need to do is to define a new object, which is going to be the goal message. And this is going to be factorial dot goal. Then goal message dot n equal to the n we have over here. Okay. Then something that is not absolutely needed, but it's nice to have, is going to help us. Is going to be waiting until the server is ready and available and taking requests, right? So we're going to call something like action client wait for server, just in case the server is not already up and running. I'm referring to this server over here. In case it's not up and running, we're going to wait until it is, right? So we're going to execute this instruction over here, and then we are going to define a new object, which is a future object, and this is going to be equal to action client send goal async, right? We have this function over here, send goal async, or we also have the other function, which is send goal, and it's not asynchronous, right? So we have the 2 functions, but it's much better if we use this one. I will say it's not only much better, but I will say it's necessary to use this one. Otherwise, we may be blocking the entire execution of this thing over here, right? It's very important. So let's do it asynchronously. And we are going to send the message we have created over here. So we have only one variable, which is n. And then we are going to call feedback callback equal to the function we created over here. Future add done callback, right? Because once we get a response over here, once we get a response from the server, we need to do something, right? So we are going to execute add done callback, and we're going to specify this thing over here, self dot okay. So basically we are defining the message we are going to send to the server. We are going to wait until the server is initialized, and then we're just going to send the goal asynchronously. We are going to define the feedback function, is this one over here, and that's pretty much all. Then we are going to receive a future object because we're going to send the goal, but we are not going to get a response immediately, right? So we're going to get a response at some time in the future. So we're going to call add done callback when this future is done, and we're going to call this other callback when that's done. Every time we send a goal, we could have the server accepting the goal, or we could have the server to reject the goal, right? So just in case, in order to make something a bit more generic, let's do it like this. I'm going to say if not goal handle accepted, I'm going to print something like goal rejected, right? because if we have not accepted the goal, if the server has not accepted the goal, that means it has been rejected. So yeah, we're just going to print that over there and we're going to return. But in any other case, we are going to print goal accepted, and then we are just going to move on, right? Now it's time to call the next callback, because now that the goal has been accepted, the server is going to work on executing the task, and now we need to send a request for getting the result, right? So now we are here. Now that we know for sure that the server has accepted the task, we will need to define a new future object. Let's call this one future underscore, and this is going to be equal to goal handle dot get result async. Okay, and now we are going to do exactly the same as we did over here, but now over here, right? And this is going to be something like this, right? So yeah, always remember this picture, and this is going to make everything much more clear. We are sending the goal, we listen for the response, then we send a request for the result, and we listen for the response of the result. And this is going to be pretty simple. The only thing we need to do is to call result equal to future. Now we're referring to this other future over here. Dot result. Okay. If we want to print the result, we can do something like this, and we can print something like result dot n factorial, right, which is the result. Okay, and now the only thing we need to do is to execute the feedback, right? This is the function that's going to be executed every time we receive a new feedback. So let's do something like this. Now let's just call get logger, and let's just log the feedback, right? Because this is going to be much easier. Feedback dot, this is going to be feedback again, and then this is called sequence, something like this. If I'm not mistaken, this is going to work. I'm following very closely the example we have here in writing the server and then writing an action, right? So we are here, and there are different ways to write this client, but the way I'm following over here is the one that's a bit more comprehensive, and we have a bit of everything, right? So I'm following very closely this one over here, and I am adjusting everything to my specific example, right? So to my factorial server. So I'm just going to save the changes, and let's go through it to make sure everything's okay. The only thing I need to do is to send the goal, right? I'm gonna do it over here. I'm going to call this function, and I need to specify n, right? Let's do n equal to 5 to continue working with the same number as before, right? We can change it later, but let's do it like that. Okay, so we're going to call send goal. We're going to spin the node over here, and that's pretty much all. This is not going to be the server now. This is going to be the client. Doesn't make a difference, but yeah, let's just do it right. Okay. Let's see what happens. We define the client over here. Then we define this object, which is the goal. Then this is n. We wait for server. We send the goal asynchronously. Then we add this callback over here. And yeah, everything seems to be working just fine. This is a very basic example, but it seems it's going to works just fine. The only thing I need to do now is going back to setup.py, and we need to do something like this. Now this is going to be example factorial action client, and this is my new package factorial action client.main. Okay, yeah. I'm going back here, ROS2, Colcon build. Okay. Now if just in case, I'm going to open new terminals, and I'm just going to execute the server again. Here. And now let's execute the client. Okay. It seems we executed the goal, right? We sent the goal, but we had an error here. Let's do it like this, because this instruction over here, we know for sure it works. This is the server. This is the client. Okay. We accepted the goal, and then, okay, we have another problem. Now this is in here. So let's do something similar. Okay. Everything is just fine. It seems we are still running the node. We should be leaving the node. What's going on? Okay, yeah, we need to do something, which is add shutdown over here after getting the result callback, right? Because once we get the result, then we no longer want the client to be active, right? We want to shut it down. So we're going to call this RCLPY shutdown. And then as we are shutting down the node over here, we do not need to shut it down at the end over here as we usually do. So I'm just going to remove this instruction, and this should work just fine. So let me show you again. I'm going to make it up to, I don't know, 7. And I'm going to initialize the server again. And now the client. All accepted. 1, 2, 6, 24, 120, 720, 5040, and that's it. And we leave the client and everything's okay. Let's see what happens if the server is not initialized. You can see that it waits until the server is initialized, and now we initialize it and everything's okay. So yeah, everything seems to be working just fine. This is how we can work with actions in ROS2. And remember, this was a very simple example in Python, but obviously we will get the most out of ROS2 actions once we start to try it out in real robots, right? In physical robots. And remember that everything I show you in these two examples of the server and the client is here in the ROS2 official documentation. And this is going to be all for this lesson. Let's move on to the next lesson. In today's tutorial, I'm going to show you how to use an Arduino Uno in order to read data from an ultrasound sensor and then communicate that data into a computer. Once we have data here in the computer, we're going to use ROS2 in order to publish the data into a topic, so we make it available to any other node that subscribes to the topic, right? This is going to be a very interesting tutorial, and although it seems like it's a very simple project, trust me that this type of project is the foundation to work on more complex projects in the future. Because once we are able to acquire data from sensors and then process that data with an Arduino Uno and communicate it to a computer, in the future we could have various sensors over here, and also we could have actuators, right? We could have motors. So the communication with the computer could potentially go in both directions, right? We could be receiving data from the sensors, and we could also be instructing all the actuators that we could have over here. So this is a very important project for sure. Now let's get started here in Arduino. We will need to do a lot of coding here in the Arduino Uno and also here in the computer. We will need to work a bit more here in the computer. This is going to be a much more interesting processing because we will need to receive all the data from the Arduino Uno, and we will also need to publish that data into our ROS2 topic. So there's a lot to do over here. So let's get started here in Arduino. I'm going to open my Arduino IDE and let me show you exactly what we will be doing today. This process is going to be comprised of two steps. The first one will be reading data from the ultrasound sensor. And then the second step will be send data to computer using serial communication. So this is going to be comprised of these two steps, and let's take it one step at a time. And I would like to go here to the computer, to everything we need to do over here as soon as possible, right? Because there's so much to do. So for now, I'm going to focus on this part over here, to leave everything up and running, to everything that has to do with the sending the data, right? With the communication. And then we can just focus on reading the data from the ultrasound sensor, right? Because there's not too much uncertainty on what happens over here. We already know how to read data from a sensor like this, but everything that has to do with the communication and with processing that data using ROS2 and everything, oh no, that's going to be so complex that I prefer to focus on this part over here first. So let me show you. We're going to start here in the setup, and I'm going to start the serial communication, but by saying something like serial.begin, and I'm going to say something like this number over here. If I go to Tools, Board, you can see I already selected Arduino Uno, and then this port over here, I already selected the port where I have connected the Arduino Uno. Then something I always have to do when I work in this type of tutorials is to provide my port the necessary permissions in order to be able to communicate data, right? Let me show you. I will need to execute this command over here. This is something I always have to do because I am a Linux user, and it seems this is necessary in my case. So now let's get back here. Let's try to see if everything works as expected. So I'm just going to print something. Let's print hey. Let's see what happens. I need to use these OR codes if I'm mistaken. And also, I am so used to work with Python that I always forget to use, for example, these symbols over there. I'm just going to save it anywhere. I'm going to save it in the desktop for now, but it doesn't really matter. Now, let's see if everything works as expected. I'm going to upload this code. Everything's okay. Now I'm going to Tool, Serial Monitor, and you can see that we are printing hey, so everything seems to be working just fine. Now I go back here, and remember, I would like to focus on everything that goes here first. So this is what I'm going to do. Every time we are using this instruction, we are sending data through the serial communication port, right? So this is pretty much everything we need to do. We need to use this instruction over here with the message, with the right message containing all the important information. But in order to move one step at a time, let's just use some random data for now, so we can focus on everything that goes in here in this computer, right? Let's just send random data for now, and we can just move on, and we can just focus on everything that goes in Python and in ROS2. So this is what I'm going to do. I'm going to send a message which is going to have this structure over here. This is going to be a string, and it is going to look like a dictionary. I would like the device in the other side to just read the data as if it were a dictionary. That's going to make everything much simpler. So I'm going to define a few keys in this dictionary. One of them is going to be measure, and this is where we will put the data from the sensor, right? The distance we get using the sensor. Then we're going to use another key, which is going to be the unit, right? Because we need to specify if these are meters, if these are centimeters, if like these are inches or kilometers, something like that. We will need to specify exactly what's the unit of the measurement we have over here. Let's call it measurement. I think it's better. Measurement. Yeah, I'm not sure if there's a typo over here. I will fix it later if there's a typo. Okay. Sorry, English is not my native language, so sometimes I have a few typos. And then something else we need to specify is the device ID, right? Because I would like to make everything as generic as possible, So potentially in the future, we could have various sensors which are sending data to the Arduino Uno and then sending data to the computer, right? So I would like to make everything as generic as possible so it fits very well future developments. And this is going to be, okay, device ID. And in order to make it work, I will need to use something like this. So I make sure each one of these characters is not read as a quote, but it's just like, this is something we need to do if we are going to create the string like this. Okay. Now, remember, I'm going to use random data for now. So the only thing I'm going to do is this part over here, I'm going to say these are centimeters. It doesn't really matter, right? This is only the unit. Then the device ID, I'm going to say this is something like ultrasound sensor. It doesn't matter either, right? This is going to be a string with some information. But then everything that has to do with the measurement, let me show you what we are going to do over here. I'm going to use a function which is called random, and I'm going to input a number like 1000. This is going to give me a random number from 1 to 1000. If I'm not mistaken, I think it's from 1, but perhaps it's from 0. I have to double check, but it doesn't matter, right? The most important thing is that this is going to return a random number. So this is going to be int random number. We can call it measurement, right? I think this is the right way to say it, right? I'm going to double check later, but it doesn't matter. So we're going to do something like this, and then I'm just going to input this data over here, right? In order to make it work, I need to do something like this. Okay, so we are going to input this measurement we got over here, right? I'm just going to send random data for now, and in the future, we are going to replace this random measurement with a real measurement from the sensor, right? So let's do it like this. Let's take it one step at a time, because everything that goes here, we already know how to do it. Everything that goes in reading data from the sensor, that's something we will be able to accomplish with very low uncertainty, right? I think the risk of failing here is going to be very low. So let's focus on everything that has to do with the communication and with everything that has to do with the ROS2 processing over here. Oh my God, there's so much risk in everything that has to do with that, right? There's so much uncertainty. Perhaps it works, perhaps it doesn't work, perhaps we need to try it many times. So let's make sure we spend as much time as possible over there. So I'm going to upload this new sketch, and then let's open the serial communication port. And now I'm still printing hey. I want to print message. Okay, let's do it again. Okay. It seems it's working. Something I would like to do in order to make it a bit more realistic is to have a bit of a delay, because once we start reading data from the sensor and we start processing this data, and also like ideally in the future once we have actuators and we have different things going on, this is going to take some time in order to execute, right? Every iteration is going to take some time. So in order to make it a bit more realistic, let's just make a delay over here equal to at least 50 milliseconds, right? We can make it a bit, we can increase it a bit later, but for now let's do it like this. Okay, this is going to slow it down a little bit, but not much. Okay, so everything is perfect. So we are already done for now in the Arduino Uno. We are already sending data with the right structure. Now from the computer side, from the everything we need to do in Python, we can just move on and we can just do everything we need to do, because the computer does not care if we are sending random data or not. Everything we have to do over there is going to work exactly the same as if it were real data that we are sending through the Arduino Uno. So let's go to Visual Studio Code. Let's continue working on the same workspace in which we worked in the previous lessons. You can see this is my new package, this is my new interface, this is exactly the same workspace, but now let's create a new package, because it's going to be much better if we create a new package for everything we need to do in this tutorial. So I'm going to call ROS2 package create. Obviously I'm going to this workspace and to the src directory, and I'm going to call ROS2 package create. The build type will be amend Python, because this is going to be a Python package, and then this is going to be called robot controller. Because although today's tutorial is going to be very simple, we're going to acquire data from only one sensor, in the future this project could evolve into something much more complex, right? This project we're going to be doing today is the foundation to more complex projects in the future, trust me. So let's call it robot controller for now, and I'm going to build using Qualcomm build symlink install. Okay, everything is ready. Now let's go back to Visual Studio Code. We have this new directory over here, which is robot controller. And now let's go to robot controller and let's create a new class, which is going to be something like our communication node. We're going to use this node in order to communicate with the Arduino Uno and in order to publish the data we got from the Arduino Uno into a topic. So let me show you. The first thing we're going to do is to start with the definition, the structure, the overall structure of our class, which is going to be something like communication node. It's going to receive no, actually it's going to inherit from the class node, and we are going to deal with everything that happens here in a few minutes. For now, let's just import from rclpy.node import node. Let's make it a bit larger just in case. You watching this video, do you think the font size is okay, or should I make it larger for future tutorials, or should I make it smaller? Let me know in the comments below, so it helps me to understand how should I work on this tutorial in order to make everything as clear and as instructional and educational as possible. So let me know in the comments. Now let's continue. So this is the basic structure of the class. And now let's work on this part over here, which is this part over here, only to make sure we are able to execute this file as a script. We're going to execute the main function, which is going to be over here, main, and this is always going to be the same process. For now, it's always going to be the same process. which is calling rclpy.init args equal args, and this is where we need to say args equal none. Obviously we need to import rclpy because otherwise it's not going to work. And then the only thing we need to do is to create a new instance of the communication node, and let's call this node something like communication node. We don't need to be super creative over here. We have enough time to be creative in all the different parts of this project, but for now let's just keep it simple. Then we're going to spin the node, communication node, and then we are just making sure that we're going to shut down everything. Okay, so this is the basic structure of our node over here, right? So now let's go back to the class definition and let's see how to work on this class in order to make sure we're able to communicate with the Arduino Uno and to do everything we need to do. So I'm going to define the constructor, which is going to be init. Is going to input self and also the name, right? This name over here. And then we are going to call the parent class constructor, and we're going to input the name. Okay. Then let's take it one step at a time and let's make sure we're able to communicate with the Arduino Uno first, right? So let's just leave everything has to do with the publishing data to the topic to the end, right? For now, let's focus on the communication. And in order to communicate with Arduino Uno, I'm going to use PySerial. This is the library we will be using today. This is going to be very straightforward. You can see that we have some snippets over here. That's a very clear way to understand how to use this library. We're going to open the communication port. Then we're going to, in this case, we're not going to send any data. We're only going to receive data. But if in the future we want to instruct the Arduino Uno to do stuff, then we will be sending data over here. And also everything that has to do with operating this communication port, right? So this is going to be a very useful library and I'm going to use it in this tutorial. So I'm going to import it and I'm going to say something like import serial. Before we move on, let's make sure we add here as a dependency the PySerial package. And obviously make sure you have installed this library in your environment, right? In this case, in this computer, I'm using Python 3.10. And in order to install PySerial, I need to type pip3 install PySerial. So it's already installed, but please make sure this library is installed. You can see that I'm working in a global environment, right? I have not created a virtual environment to work on this project because I want to keep it simple for now. But if you're working in a virtual environment, it's the same idea. Just make sure you have installed PySerial before you continue. Let's go back here. And in the constructor, we are going to open the communication port. So I'm going to call this variable serial port, and this is going to be serial.serial, and we need to make sure we are accessing the communication port. Remember from the Arduino IDE, this was TTY-ACM0. So this is dev and then TTY-ACM0. Okay. And then the baud rate, which I have set in this number over here. This number over here obviously needs to match whatever number you have set here in the Arduino Uno, right? Whatever number you have specified over here as the baud rate, make sure you're using the same number. This is the baud rate. This is how fast you are sending symbols through the communication port. So obviously you need to receive data at the same speed at which you are sending the data, right? Otherwise this is not going to work. And that's going to be pretty much all for opening the serial communication port. Then we will need to make sure we are processing the data we receive through the port. So this is how I'm going to do it. There are various ways in which we could do it, but this is the one I'm going to do because this makes everything very simple and we want to keep things as simple as possible for now. I'm going to define a new timer, and this is going to be self-create timer. I'm going to call this timer every 1 second. For now, we can adjust this in the future, but for now it's 1 second. And this is going to receive a callback, and this is going to be something like read serial data. Now I'm going to define this callback over here. This is going to receive self, and that's pretty much all. And this is the callback which will be executed every 1 second, and this is the callback we will be using in order to read data from the serial communication port. Let me show you. So this is a way to do it which is going to make everything super simple. It may not be the best way to do it for different reasons, but it's going to be a good enough way to do it for now. Let me show you. So I'm going to call data equal to self serial port read line, then the code and strip, right? The code is very important because this is going to take care of decoding all the message you got over here and to put all the data into a format in which you can then use, right? This is very important and it has to do with the communication. Then strip, what we are doing over here is basically just removing the last character, which is the new line character. So this one over here is not super important, but yeah, that's basically the purpose of having this function over here. Then once we have received a new data element, we're going to do something like that. If we have received something, we are going to say, we're going to define a new object, which is data dictionary. And this is going to be json.loads data. We need to import JSON. Remember, we are sending the data with a given structure. We have a dictionary over here, so we need to make sure we are able to do this, right? We are just decoding the data as a dictionary, right? As if it were a dictionary. And then for every element we have here, for now, in order to keep it simple, let's just print this over here, right? In order to keep it very simple for now. Then obviously we will need to take all the data, we will need to publish the data into a topic. Yeah, there are many things we will need to do next, but for now let's keep it simple. Let's make sure it works. So I'm going to save the changes and then let's just compile it again. I think this part over here, we don't really need to compile it again because I built the project using Symlink, but let's do it anyway. So ROS2, ROS2 workspace, then Qualcomm build Symlink. Okay, and now I'm going to ROS2 run robot controller, and then this is, I need to create the executable. I almost forget. So let's go here to setup.py. I need to create something over here. This is going to be equal to communication node executable equal to robot controller dot communication node, and this is the main function. Yes. Okay, save the changes. Over here, let's build it again. Okay, ROS2 run robot controller, and then communication node executable. Actually, this is going to be serial, no, sorry, self get logger info something like this. Okay, I was debugging for a few minutes. I didn't realize I missed a character over here. Okay, now everything should work just fine. I was debugging, so there are a few prints over there. Let's execute it again. Now we have this error here, could not open port, not a directory, because this thing over here is also wrong. Let's do it again. Okay. Let's see exactly what we get over here. So I'm going to print data. Let's print okay. So we were able to read data from the serial communication port, but you can see we did not read an entire line, right? We got like a chunk of the data, but we didn't get like the entire instruction we are sending from Arduino. In my debugging efforts, I closed Arduino, I closed everything just in case, but now let's open Arduino again. You can see we are sending all of these over here, right? But it seems we are getting only a chunk of that data. This is why we are going to do something else first, which is we are going to try to read this data. So we are going to call try. This else over here we don't need anymore. And we are going to be trying to catch this exception over here. The exception we got was JSON decoder, JSON decode error. Okay, so every time we try to read this data as if it were a dictionary and we are unable to do it because we got only a chunk of that data, we are going to call this we are going to catch the exception over here, and then let's just move on, right? Perhaps we can log it for now, but then in the future we're just going to move on because we don't really want to read every single time we catch this error over here. So this is going to be something like perhaps error JSON decode error, something like this. Only to have some information for now. Let's try to do it again. And let's see what happens. Okay, you can see that we are getting this error very often, but also in some other cases we are able to read the data we want, right? This is the measurement we got in this case, this is another measurement, and so on. So it seems it's working. We have a few issues, but it's working. So this problem over here of getting a data chunk, an incomplete data chunk, we are going to solve it like this. For now, we're just going to solve it like this. And then we have another problem which is not very easy to realize only by looking at this data over here. Remember, we are sending data continuously through the communication port, right? We are, in this case, we're just sending random data, but in the future, we're going to be acquiring data continuously and we are going to be sending data continuously. And the way it works, if we're going to create some sort of robot controller, we want the robot to take actions based on the most recent data. We do not want the robot to act based on data which was sent a very long time ago, right? We don't want the robot to make decisions, to take actions based on data which was acquired a very long time ago, because the robot is going to be completing different missions and different tasks, and they obviously need to take into consideration the data which is being acquired live, right, on real time. We need to make sure the communication is on real time, otherwise nothing is going to make sense. So there's something else we need to do in order to make sure the data we receive is being acquired recently, right? This is the most recent data we have acquired from the sensor, and we are just going to call serial port reset input buffer. Right, so every time we trigger this callback over here, we're going to reset the input buffer first, and then we are going to try to read a new line, right? So we're going to remove all the data which is currently waiting in the buffer, and then we are going to read a new line. This is going to take care of always being acting according to the most recent information, right? This is going to work. This is not an ideal solution. Let's put it over here. To do. Not an ideal solution. Fix. So we will fix it in the future because it's not an ideal solution, but it works very well in this case because we're just going to clean all the data and then we're going to read a new line. So we are sure that this new line was recently sent through the communication port. Let me show you. If I try to execute the same process again, you can see that we are still getting errors. The errors don't really matter so much, right? But we also have measurements, and in this case we can trust the measurements are recent, right? They have been acquired recently, because every time we are calling the callback, we are resetting the input buffer, right? We're just cleaning the buffer. We're clearing all its content before we read a new line. So yeah, this is going to work just fine. I can tell you that me personally, I like this solution a lot because I am very sure, I'm 100% sure that every time I'm reading a line over here, or this has been acquired recently. This is a very fresh piece of information, right? I am pretty sure that this is the case. But I was discussing this solution with Claude before I create this video, when I was preparing this tutorial, and Claude did not like my solution at all, right? I'm referring to the AI, right? Claude, the AI. Claude proposed me a very complex solution. Perhaps I can show you later in a future tutorial, but I like my solution a bit more because it's very simple too, right? Let's remember we are still getting familiar with ROS2, with how to work on projects, with Arduino Uno, with everything we're doing here, right? This is new. This is new for many of you. So I want to keep everything as simple as possible, and I like this solution a lot because it's very simple. Yeah, Claude's solution was very complex, was overly complex. It's not something I can do in this tutorial because it's going to be very confusing for many of you. And also, I really like to focus on what works, right? I really like to focus on functionality. And this solution over here, I have already been working on this project for a while, and this works very well. I process very recent data at every single time, so it works very well. So now let's move on. What we are going to be doing next is creating a new interface, because we need to get this data and we need to publish this data into a topic, but in order to do so, we are going to create a new interface. So let's go to this package over here, my new interface, and I'm going to create a new directory which is called message, and message is going to contain a file. I'm going to create a new file which is distance.msg, and this is the interface we are going to be creating. So remember, this is the data we are sending. We're sending the measurement, unit, device ID, and that's pretty much all. So for the measurement, we are going to define it as a float 64 data type. So this is the first data type, which is measurement. Then we're going to define it as a string. We're going to find the unit as a string, and then we're going to have the device type, the device ID, which is also going to be a string. Okay. And now remember, we need to go to CMake lists, and we need to add this new interface over here. So this is going to be message distance.msg. Okay, now let's go back to some terminal. Perhaps I can do it here. Colcon build symlink install. I'm here in the workspace. Okay, I have a lot of errors. Let's see what happened. String, they didn't like the string. Huh. I get confused with so many different programming languages. Let's see now. Okay. Show my new interface, message distance. Perfect. Okay, so now we're going to import this data type over here. From my new interface.message, import distance, and let's make sure that we have this type over here in package.xml. So I'm going to say something like depend. Okay. Perfect. And now this is what we are going to do. We're going to define a new object which is going to be called message, and this is going to be a new instance of distance. Then message.measurement. Let's try to see if this is measurement or if this is type. Yeah, this is okay, measurement. This is going to be equal to data dict. Actually, if we're going to do it like this, we don't need to do it like this, right? Yeah. Okay. This is measurement. And then unit, and then device ID, device ID. Okay. Then we need to publish this data, this message into a topic. But that's pretty much all. Yeah, this part of here is done. And that's pretty much all. Okay. Yeah. So now let's move on to creating the topic and publishing this data into the topic. Okay, I'm going to do it over here. I'm going to create a new publisher. Self.create publisher. This is going to receive the instance as the interface, and then the name of this publisher, the name of this topic, let's call it something like name, and then sensor data. Okay, and then the only thing we need to do is to publish like this. So self.publisher.publish message, and that's pretty much all. Let's see if it works. So I'm going to run it again. And then communication node executable. QoS profile. Okay, yes, I forgot. Let's set it in 10. Is this argument over here? We need to set this argument. I forgot. Now everything should work just fine. Field must be float. And we may be receiving all the data as a string, right? Yeah, we're receiving the data as a string. So we need to cast it as a float. Yes, we are sending the data as a string. So let's try again. Okay. We are still logging this data over here. We don't need to log this data. Okay, now we are going to print the errors, but we don't want to print the errors anymore because we just want to publish the data into the topic and that's it. Okay, now let's see if we can listen to all of those messages which are being sent to the topic, right? Let's try to subscribe to this topic. Let's try to see what's going on in that topic. So I'm going to run ROS2. If I'm not mistaken, this is topic echo, and then the name of the topic. Perhaps I can do ROS2 topic list. This is the topic we are using in order to publish all the data, and then ROS2 topic echo. And you can see we are getting data from the sensor. We're getting all this data we are receiving from the Arduino Uno, right? This is huge. This is huge. I understand this is a very simple project, but at the same time, this is very important because we are acquiring data on real time from the ultrasound sensor. We are acquiring this data using the Arduino Uno, and then we're communicating the data into our computer. And from there, we are publishing the data into a topic. Now, any other node that's subscribed to this topic will be able to receive this data on real time. This is data which is being acquired on real time, and it will be able to do stuff, right? It will be able to make decisions, to take actions, to do stuff, right? This is huge. Okay, now it's not really data because we're just sending some random information, but in the next step in this tutorial, now we're going to use the ultrasound sensor in order to acquire measurements, real measurements, and from here, oh, now everything is going to make more sense. So let's move on to the next step. Let me show you the physical connections first. You can see I'm using an ultrasound sensor of 4 pins, and the 2 pins in the extremes, right, this one and this one, is VCC and ground, right? So we need to connect them to the Arduino Uno. And then the other 2 pins are the trigger pin and the echo pin. Make sure you connect them to the Arduino Uno as well. You can just use pretty much any pin you want because these are going to be digital guides. I'm using the pin number 7 and number 6, and you can see I have attached this USB cable over there. And I am going to use a support I have over here because I am preparing another project where I'm going to use a robot like this, a very simple robot like this, and I'm going to use it also with an ultrasound sensor. So I have this support attached over here, and it's going to help me a lot in order to make tests in a few minutes. So I'm just going to put the Arduino over here and then the sensor on this support over here. Okay. I'm going to show you in a few minutes. This is going to help me a lot because I can just put my hand in front of the sensor like this, and then I can just see how it works, right? You can see I have this other camera over here. I'm going to use it so I have another perspective on the project, and that's pretty much all. So now let's continue with the tutorial. Okay, now let's see how to get data from this sensor over here. Everything is connected, everything is up and running, and the only thing we need to do is all the coding over here in order to get data from this ultrasound sensor. Let me show you. So I'm going to define a couple of constants. So define trigger pin. This is going to be the number 7, and then define echo pin. This is going to be the number 6. Now remember how this ultrasound sensor works. We're going to have these two things over here, and we're going to emit a pulse in one of these things. Then the pulse is going to be reflected in the object there will be in front, and it's going to return to the sensor over here, and it's going to be perceived by this other thing over here. So we're going to compute how much it takes for the pulse to be perceived in the other thing, right? Let me show you. This is going to be very clear once you look at the code. So I'm going to define two variables, duration and distance. These are going to be long, right? The long type. And this is what I am going to do. I'm going to send a digital write to the trigger pin, I'm going to write low. Then I'm going to wait a very short time, only 2 microseconds, and I'm going to write high, right? So I'm going to take it to low for only 2 microseconds, and then I'm just going to write 1. Okay, and then once this is high, I'm going to wait now for 10 microseconds. And then I am going to send it, I'm going to make it low again, right? So I'm going to do something like this. Okay. Let's make it like this so it's a bit more clear. And then what I'm going to do over here is to measure the duration, how much it takes for this pulse to be perceived in the echo pin. So I'm going to do something like this, pulse in. This is a built-in function in Arduino in the echo pin, and this is high. Okay. So I recommend you to read the Arduino documentation about this function because it's going to make it a bit more clear what this function is about, right? It's going to make a bit more clear exactly how it works, and I definitely recommend you to check it out. Once we have this duration over here, sorry, this is a bit over here, right? Over here, okay. And once we have this duration, the only thing we need to do is to compute what's the distance, right? Remember, this is going to be a wave that is being propagated in the air. So the way to compute the distance, the first thing we need to do is to divide this duration in half, right? Because this is how much time it took the wave to travel to the object it has in front and then to return, right? So if we want to know the distance, we need to take this number and we need to divide it in 2 because this is twice the distance, right? The wave traveled all the way up to the object and then it returned back to the sensor. So this is twice the distance. We need to divide this number by 2. And then we need to multiply this number by the speed of sound, right? Because it's a wave that is being propagated in the air. So it's going to be this thing over here, the speed of sound. So we're going to multiply it by this number over here. This number is in meters per second, and from pulse in, we're going to have the duration in microseconds. So we are going to take this number, and we're going to divide it in 1 million, right? We're going to divide it by this number over here because we want to take it to meters per microseconds. Okay, and then these are meters, right? But ideally we would like to have this distance into something like centimeters, right? Because it's going to be a bit more clear for the distances we have here, right? So this is going to be multiplied by 100 because we have 100 centimeters in 1 meter. So we have this number over here. I'm going to take this number and I'm going to multiply it by this other number over here. And that's pretty much all. So this is the distance we are going to measure at every single time. And then the only thing we need to do is to set up these pins, or otherwise it is not going to work. We're going to say the pin mode of the trigger pin is going to be an output. Okay. And then pin mode for the echo pin is going to be an input. I recommend you to search online on YouTube and different tutorials on how the ultrasound sensor works, because it's a very simple technology and it's a very good way to estimate the distance of objects, right? So I definitely invite you to check it out and you're going to understand this thing over here much better. For now, let's just continue, and I'm just going to upload this sketch. Oh, I may need to provide permissions again. So I'm going to run this instruction over here. Okay. Let's see. Oh, I forgot this thing over here. Okay, let's see if it works. Now let's remove the random over here and let's just input the distance. And we are so close, right? We're almost there. We're almost there. Let's go to the serial monitor. And you can see it says 30, 40. Yeah, it seems it's working well. I'm going to turn on this other camera I have over here so I can show you. You can see we have the sensor over here. This is my hand. And you can see kind of makes sense, right? Kind of makes sense. 8, 6, 4, 3, 2. Yeah, kind of makes sense. So now let's continue. So everything that has to do with Arduino is ready. I told you this was going to be a very simple process. Everything that has to do with getting the measurements from the sensor was going to be a very simple process. Now let me show you. The only thing we need to do is to test the overall system. Let me show you how to do that. I'm going to open a terminal and I'm going to call the same controller over here, robot controller communication node executable. Now we are publishing all the data into a topic. Let's see if it works. It seems it's working very well. And let me show you something else. You remember we were doing this process every 1 second. Let's do it a bit more often. Let's do it every 100 milliseconds. I'm going to run it again. And you can see that now we are getting measurements much more often. And also you can see that everything seems to be working just well. It makes sense. The measurement is updated in real time. If I make my hand a bit closer or a bit farther away, you can see the numbers are being updated in real time and everything is okay. So everything seems to be working just fine, and this is going to be pretty much all for this tutorial. So remember what I told you over here. This may not be an ideal solution, it may not be perfect, but it definitely works pretty well, because the only thing I care about is to have those measurements to be updated in real time, right? So as long as everything is updated in real time, I am happy. Right? It may not be a perfect solution, but I am very happy. So this is going to be all for this tutorial. Let me know in the comments below what you think about this video, and see you on my next video.